almost everyone owns a mobile now. So that way, when these instruments came, apart from text, they were able to handle voice, they were able to handle images, etc., etc. So the volume of data also came up, and at the same time, the variety also got increased. And slowly, I think what Gartner predicts is in another, I think 20 years of time, in another 5 to 6 years of time, non-numeric data, what we call the alternate data sources, they will become almost 75%, and your what we call the conventional type of data, that may come down to 20. So it is high time that we start to use this alternate data source to our advantage, and particularly with so many social media coming, Twitter, Instagram, Facebook, LinkedIn, etc., etc. Most of them, I think they handle non-numeric data. The data generation itself is non-numeric. So that way it is all pictures, images, voice, etc., etc. So they are little bit different to handle. And our earlier computers, yes, they were not capable of handling that much volume. So these applications were not developed about 10 years back or 8 years back. Though some of the algorithms we use now, they were there. They were even existing 15 years back or 20 years back. They were still there. What has happened is we made them to apply for this type of alternate data sources. That is one part. The second part is the interpretability of those data, what we call the explainability of that data, that got increased. That is where it is. All of you know, even if you take a simple regression, earlier it used to be very difficult to explain that regression output to a non-mathematician or something. Some mathematics person was required to interpret that output. Now with the advancement in our computer technology, natural language processing, all that, that same regression output can be translated into some 10-15 sentences, and that can be presented to the top management. Because if you tell to the top management R square is 0.9, some t value is some 2.2, standard error of the estimate is etc., etc., they will say we can't understand all that. What all he will ask is if I reduce the price of my product by 10% or 15%, what will happen to the market share? That's what they want. He is least worried about your R square, TP, etc., etc. They will say, what do we do with them? What we need is some type of action we have to take. Some of our strategic objective has to be met. So you explain to me what is it that happens. So that way this whole output has to be somewhat presented in a different way. That is what nowadays with all these natural language processing, etc., etc., some of those outputs we are able to convert that is called explainable AI. We will not be able to touch that today because that itself becomes another session. This is what we call XAI. What all it does is most of these models will output some type of a cryptic type of information which requires again an expert to interpret and translate it to a common format or a common type of language. That is what this text analytics comes into picture. How do we convert those type of some numerical outputs which only an expert can understand and somehow translate it into a language? This is what we call storytelling, so that the general top management who are not technical people or who do not know text analytics or model building, whatever you want to call it, how will they understand and get confidence in the system? Unless we build confidence in the system, none of our what we call the machine language models, it will not go to the field. Somewhere the trust has to be built up. To build the trust, you will have to speak in a language in which they will understand. That is one application of text analytics, where all that numerical output of the neural network, decision tree, whatever you want, you will convert it into some type of a one A4 sized page or half a page, and then give it to them. That is the another application of text analytics. It has a lot of other applications also. What I will do, most of these course material are already there. I will mail all of them to you. Sudeep will mail. We will not spend much time on this PPT and other things. Just to give some background, I will go through some of these slides which tells what are the applications where text analytics plays a bigger role. Now the second issue where it comes again into picture is, see, most of the data is in the form of a voice nowadays. Now voice cannot be directly analyzed by the computer. So what happens is voice gets converted to text first. Now we use all these text analytics tool to do further analysis. Then the output of the text will again get converted to voice. So that way text analytics plays an intermediary role when you want to analyze data from voice. Now lot of advancements have taken place in computer vision. Now the output of computer vision is somewhere a picture only again, or it may be sequence of pictures. How do you convert the sequence of pictures to a text? This is another big research area that is happening. How do we generate text from the image? Because the output of your computer vision is not a text. It puts an image, or it may be sequence of images. It may be more than one image. Now what happens is, can I create a story out of these pictures or somehow convert this pictorial output to voice again? No, voice or either text, okay, it doesn't matter. If you want to convert to voice, I will convert to text first. And then there is a text to voice converter which converts to voice. So that is another big area where your text mining plays a role. The third one, all of us know, most of our country is still illiterate. Majority of the people, majority of the public are who live in rural areas, even they may not know how to read. Now there is a newspaper, even they don't know how to read, So what do? You scan that newspaper, that is a text. We convert the text to voice. And he will listen the voice. It is almost equivalent to himself reading a newspaper. That is another area where this text analytics comes into picture. And there are a lot of these tribal languages, I think, which may somewhat become extinct. And even they are not able to read the newspaper in other language because a tribal language doesn't have much newspapers. So what happens is, you take a picture of that, a picture of the language which is closest to that tribal language. For example, there are a lot of tribals in Karnataka also, interior of Mangalore, all these places. So we have Kannada newspaper. So what we do is, you take a picture of that Kannada newspaper, scan the newspaper, take the picture, convert that to his language. Using a dictionary lookup, thus we will speak. How do we do it? So convert, and then convert the text into voice again. It will help them the literacy also. This is another big area where text analytics can be used, where most of these tribal languages are spoken languages. They do not have in the script. So a lot of languages there. I was told there are about 900 to 1000 of them sitting in my own country, and we don't have even newspapers in those languages. It's not there. The closest newspaper may be Hindi, or it may be English, it may be Gujarati, Marathi, whatever it is. Somehow that has to be converted. So this is other area where text analytics plays a role. Maybe I assume there may be a very number of students also listening to me. These are some of the research areas where plenty of opportunity exists. How do we convert voice to text, text to voice? Then again, tribal language, spoken language, it doesn't have a written script. So how do we do all these things? Converting this picture to a voice or a story. Again, the reverse also. Converting a story to picture. It is both ways. We have something like a story written somewhere. Can we convert and then see what happens if we convert to a picture that is from text to voice? The other one is from voice to text. So those things I will not be able to speak today. I just wanted to give a brief overview of where this technology is and where are we going like that. And the next thing is indexing the videos. See, what happens is, we don't have an index for the video. If you download a video from your YouTube or wherever it is, if you want to somewhere skip to your liking, you will have to again go from the beginning. Approximately you will have to move that video. That is again can be done by text analytics, because video is a voice, index is a text. So how do we convert? How do we make some type of a index out of these videos? That is again text analytics. It is both voice and text. Anyway, I told you we will convert voice to text. So we somehow convert voice to text and then use this text analytics, identify some what we call the important keywords in that, and using that we will be able to index that video. This is other big application where text analytics plays a major role. That is one part. The second part is all these spam emails, all of you may be knowing. So how do we automatically identify that spam and somehow put it to another mailbox or whatever it is? That is another application where text analytics is used. Identifying the fake news. Identifying the fake news is another important area where text analytics plays a major role. That is one of the biggest applications of text analytics. All of you know, whether it is Twitter, whether it is LinkedIn, or whether it is Facebook, this identifying the fake news and how should it be removed, that is a very big issue, because there may be some regulatory compliance also they will have to satisfy. So it becomes impossible to read all these millions of tweets and millions of Facebook posts and then manually try to remove them. Of course, our machine will not make 100% accuracy. It has not come up to that stage. But even if we classify 75% correctly, those 25 only you can read, instead of reading all the 100. It's all right. We are not claiming any machine will make 100% or 99% classification accuracy. We do not have. Even if it is 80, 85, even if it is 75, it saved a lot of your effort. Roughly 75% of your effort it saved. Now what you are doing is, whatever the news got misclassified by the classifier, by the text classifier, only that you read and then try to reclassify, instead of reading all these 100% of the news and trying to classify. That is other important area where this text analytics can be used. And again, coming to these call centers, your support centers, what happens is automatically that query will go to a bot. Now if that bot can answer, it will answer the query. So if it cannot answer, it has to be escalated to the next level. That means it requires some type of a manual intervention to answer that query. So instead of all the queries handled by a person itself, it has cut down the work drastically. Even if we can handle 60 to 70% by these language translation, by these text analytics, and if that bot can answer that question, that itself saves a lot of time. And language translation, your customer may be in Sweden or Italy or France, they will speak in their local language. We do not have this part trained translators in my country to do all these translation. Where are the translators? So the machine translation, that is again a branch of text analytics. Exactly, that is a branch of text analytics where we take one language and then try to convert to another language. It is not that simple because there is something called the semantic part of the language that is difficult to capture compared to the what we call the syntactic part. I will give a simple example. Let us say somebody calls me to dinner. I will answer him, probably, let me see. Second person will say, I am not very sure. Third person may say, are you joking or what? Something like this. Now, if you give it to the text analytics classifier, it groups them into 3 different sentences. But semantic meaning is the same. There is an uncertainty in coming to dinner. That is the semantic part. Whereas the syntactic part looks totally different. So I told him, let me see. I will call you tomorrow and then let you know. Somebody may say, are you joking? Somebody may say, out of station. What all this means is, there is an uncertainty in coming to the dinner for his house. But unfortunately, even today's, whatever the sophisticated text analytics tool you take, no, it is not able to extract this, what we call the hidden information in these 4 sentences. The hidden information is, no, I am not very sure. And the third candidate may say, I am not very sure. That also he will tell. But unfortunately, it gets bugged off. Somewhere you will end up with three sentences if you do a cluster on these four sentences using text analytics. No, 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 you will not get one cluster, you will get four. But anyway, technology is going, I hope we will solve it one day or the another. This is another research area for all the students and other who are listening, who want to do some work in the R&D in their own organization. How do we extract the semantic part of the meaning of these different sentences? And it may be only one sentence, that is one part which is still there. And automatic summarization of text is also not there. If I give you 100-page research paper or 40-page research paper and assume that abstract is not there, or you feel that abstract is too small, it is only 10 sentences or 50 sentences, you want that to be 100, so that you want somewhat an in-depth type of abstract. Not all that 30 pages or 50 pages you don't want to read. So you want that abstract to be made from 30 sentences to 70 sentences. That is called the text summarization. That still is not up to the mark. It uses text analytics, but we have not come up to that level where you can say, okay, I have fed a 50-page document, you convert it to one A4 size. Second person may say, no, 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 one is too small for me, I want two A4 pages. And third person may say, no, no, I want only 40 lines. That level of sophistication is still not there. I hope one day it will come. I think this is the brief idea. What I will do, some one or two applications, most of them I have spoken orally because somehow I feel these PPTs will tie up a lot of time. Normally I speak extempo. I normally don't go to these PPTs because the same thing, if I go by PPT, it would have taken 1.5 hours for me to cover. Then what am I left with to show you hands-on? I normally do not do it. Anyway, one or two slides I will show, and then I will go to that hands-on and explain how KNIME is used. And by the by, for all the participants who are listening, KNIME is fully open source. There is no restriction on the number of records or anything. Some open source tools have restrictions. For example, KNIME, the most closest competitor for KNIME is RapidMiner. The other one is called Head2O.ai. The third one is SAS Systems itself. Now, most of those have some restrictions on the open source platform, and certain modules, for example, explainable AI, there is something called developer app. How do we move the model which you develop to your production? There is a big work that has to take place. And when data changes, automatically the model has to change. Now, manually doing will be very tough. When to retire that model, when to push your other, that is called a challenger model. When to move the challenger model to the production, these things manually it is tough to do. And most of those open source tools, these type of modules will be charged. What is free is only some basic statistics and little bit of image analytics and some text analytics, not sophisticated. Whereas KNIME is fully open source. Last week I wrote to the CEO of Mail to clarify this issue. He clearly says, yes, commercial application KNIME can be used without paying any money. Unless you host it on their KNIME server, there is some charge. Otherwise you host it anywhere, no, it is completely free, even for commercial purposes. This is the only open source software that doesn't take, they will say some out of these 100 modules, 30 only is open source. If you want to use balance 70, you pay for that. No, there is no such thing. That email also, that original email which I have received from the CEO of KNIME, I will circulate it to all, and maybe if any other clarification is there, he will be very happy to clarify all these things. Backend of KNIME, I think 80% of the backend of KNIME is Python. That way it generates a Python code at the backend. So if you have that KNIME developer, what happens is it generates a Python code. You can edit the code. Why do you want to write the whole Python code? Particularly this explainable AI, a developer app and all, no, writing yourself will be tough. It's not that simple, and there is a terrible shortage of manpower in our own country also who can handle this type of work. No, or if you are prepared to pay them whatever salary you ask, that is a second alternative. You can always get them. But otherwise it is quite expensive to get this type of manpower also. So that's why NIME is openly free, completely free. That's why I use that software. It is an end-to-end software. You start from your basic statistics like mean, median, etc., etc. All your decision tree, XGBoost, all the ensemble trees, then text analytics, image analytics, voice to text conversion, web scraping tool. I think whatever you ask, I think that is one software which I will find everything in that, right from one end of the spectrum to another, including your developer app, and then explainable AI, that shape layer values, all that. That is there. That is there. I used this name for the past almost 3.5 to 4 years when it was under beta testing. I also advised them what additional features can be put into that. So that is the brief summary of NIME. I will show you the NIME also, how easy to develop a workflow in half an hour or 45 minutes. Whereas you will almost take 10 days to develop the same application if you go to a programming language. And the moment you write the Python code, there are other issues to move it to the production. So what happened? The same issue comes. Who tested the software? What type of data is being given? Have we documented this to CMM level 3, CMM level 4 or CMM level 5? Unless some of this quality comes into picture, normally the software what is developed will not be normally moved to a production. It will not happen. You may build the model, experiment, but what happens is, if you want to market that software or give it to one of your client, the first question they ask is, who tested? Is it a CMM level 5 organization or CMM level 3? All this comes into picture. So that part also you will have to keep it in mind. I will just go through all these. I will circulate. You don't have to take down or don't start writing all these things. These are the things, opinion, and particularly the stock market is another area where text analytics. See, what happened is all these days we were only using the numeric data to do some prediction or when to buy, when to sell, etc., etc. None of the models, none of the financial models today use news. They were all built about 15 years back, 20 years back. They don't use this alternate data sources at all. So using this alternate data source, whether it is an option price, whether it is a foreign exchange rates, or even our market itself, there is something called algorithmic trading, where you will have to trade it in fraction of a second. The computer has to take a decision whether to buy, sell, hold. For those type of thing, news plays a major role. So normally what happens is we get a real-time news feed to that. Along with your financial models, we extract the sentiment from that news. So the sentiment goes as an additional input to the news, and we will be able to predict the prices much better than using only the financial parameters. I think this is one demo which that Capco expert will be speaking after my talk. That model can be still improved. There is a scope for improvement, but still it shows the power. Option trading, all of you, some of you must have heard that Black-Scholes formula which computes what is called an option price. Option pricing does not take news into effect. No, it just goes by the your price data, the volatility data, and some risk-free interest rate. It doesn't take news. So the market reacts to the news. That is why you must have seen there is something called a volatility indicator, what we call the VIX. VIX is moving very fast now. The reason is the news. It is not that fundamentals of the company has not changed in a day or in 24 hours, in 48 hours, what fundamentals have changed. It has not changed. Then why the volatility of the market is so high? The volatility of the market is so high because the markets are getting integrated. It is a global market we are handling now, and there is a lot of news that is coming in different parts of the country. That is what is contributing to your volatility index, what we call the VIX. There is a VIX India index also. It started from Chicago Board Option Exchange. So we have a VIX India. If you look at the VIX India, there is a terrible volatility. It is not caused by the fundamental of the company. It has not changed in 1 week or 10 days. How it will change? So then what is the reason for change? One of the major reason for change is textile, is the news. You call it news. News we convert to a sentiment, that I will tell you how to do it. And that is what goes as an input. This text news you cannot combine directly with your original models and try to analyze. No. That is not the way. What we do is we extract what is called the sentiment from the news, and that is the input that goes along with your earlier model parameters. There is no issue there, and that is how it increases the accuracy of your models when you take your text also into account. This is what it is. And all the marketing, most of the marketing campaigns have become digital. Either they go to Instagram or their own company sites, and most of them are in the form of a voice. So how do we analyze the sentiment that is expressed in that video or voice? Voice we will convert to text, the text will convert it to a sentiment, and that gives the, I think probably that influences the purchasing decision of the company also. And if you take any e-commerce sites, there are a lot of reviews that go. So most of the time what you do is, before you buy a product, definitely you will go through some of the reviews. So they play a major role in the buying process. You just don't use only numeric data telling that okay 10,000 products were sold, I am going to buy. No. That was there in the earlier days. Where you are not having access to other source of information. But no, you are not going by that. Okay, it's alright, 10,000 or 15,000, let me look at the reviews. So you read the positive reviews, you read the negative reviews. Now what happens in all the positive reviews, they capture certain keywords. If you go to either Flipkart or Amazon or any e-commerce site, you will get some keywords in those reviews, you know. So what happens is, if you click only positive reviews, you get all the positive keywords. And if you click those reviews which has 2-star or 3-star rating, probably they are negative reviews. So you will not be able to read all those negative reviews. So what you do using text analytics, we extract the 10-15 negative keywords. So when you click it, the 2 or 3, you will get all the negative keywords your buyers have put in their reviews. So you cannot read manually. If you are buying some 10 products or 30 products, how will you read all these negative news alone? Again, it comes in the big, the volume is also very high. So it is not possible to read. That is another area of text analytics. It is called topic modeling. Automatically, how do we extract keywords from the text? There is something called a chi-square keyword extractor. Another one is based on the network. The third one is based what is called the topic modeling. It uses what is called a latent deleted algorithm to extract the keywords. I may not be able to teach all these things, but you will get a feel. I am just giving an overview. So these are the 3 ways, and all the 3 probably they don't extract the same keywords. So one method of analyzing is take all the common keywords from all the 3 models. Probably they are the strong keywords rather than going by one model alone. And in most of the analytics work, we do not build one model, whether it is text analytics or numeric computation. What we do is we build more than one model, depending on whether it is a text or a number. Either we take the average or weighted average or text. I will tell you how to handle that. I have not told it today. That is what we call the ensemble learning. Instead of taking one expert and relying on him, we don't go by one expert. We will go by majority. If I build 10 model, 7 says this news is negative sentiment, and even though 3 may say positive, we will classify as positive. This is called ensemble learning. So that is another area itself. I will not be able to cover all of them, I think, today. I have just given a brief overview. So what I am doing, I am not going through any of these PPTs. This PPT part has almost come to an end. I will just show you what are all the I don't know this.
Sir, you have to press escape.
Escape only I am pressing.
Okay. Maybe you can stop sharing and come back again.
Okay.
I I see there are three questions. Let me know when you would like to take them.
No, I can handle now. There is no issue.
Perfect. Sir, I have a question from Kanchan, who is asking, what is the accuracy of the sentiment analysis to the real character of a person, and what are the key components sentiment analysis and the process of starting a sentiment analysis model?
In general, all the sentiment analysis model, they depend on the volume of news also. That is the first thing that plays a role. So as far as my experience goes, it goes between 70 to 80. I think that is very realistic, even though on some data it comes to 85, 90 and all. On a general data, it comes to somewhere between say 65, 66 if the data is too bad, not pre-processed properly, and if you pre-process the data properly, it may go up to 70 to 75.
Sure. Question from Sharat, who is asking how to convert emotions in pictures to text automatically.
No, not today's class. Oh, I think this will take another session, my dear. Because what happens is I worked in ISRO for almost 10-15 years. I am very familiar with that image analytics at least, but converting that image to text, I don't think today we will be able to cover. I will have to go to all that convolution, neural network, etc., etc. A different type of class comes into picture. We will definitely do it with NASCOM at some other point in time. It becomes another session altogether. We can't watch
his question is there progress in this area?
There is a lot of progress. IIIT, Hyderabad, some of these Indian institutes are also doing. There are a lot of MIT, Stanford, Carnegie. There are a lot of people who are doing in this work. It is a very good area for research.
Sure. And I see few more questions coming in. Venkat is asking, any social and sentiment analytics tools available from Microsoft, GCP or Google?
Correct. They are available, but most of them give you as a Python API. So it is not a GUI based tool. Most of them, they give the APIs. So again you will have to use, right, again you will have to load that NumPy, Pandas, Scikit-learn, all those dependencies also will come into picture. And the second issue with that is one module gets updated, something gets updated, then suddenly your others will stop working now. So unless constantly also you go to that Conda environment or you go to PIP environment, handle all the dependencies and all, whatever model work today, maybe I don't know, maybe after 1.5 months or 2 months something may stop working also, unless the other side handles all these dependencies. See, all of the modules are not written by Microsoft. Definitely something they will take from GitHub, something comes from some other libraries. Unfortunately, what happens, one problem with this is, if those versions are not updated and if this fellow updates the version, there are cases where the existing software or existing code which the developer has written, suddenly it may stop working.
Got it. So more questions there. Is it okay to take it up now?
Yes, sir, I will complete so that whenever it is fresh, we will answer this.
Okay.
That is much better.
So there are 4 questions and let's take it up.
Yes.
Then we can start with the
Definitely. Now with our demo, I will start.
Yes. So Ravi is asking, how can we convert image into text?
I answered this, my dear. No, we will handle it separately. No, I don't want to mix. No, because the total basic foundation itself is a little bit different. So merging the picture with the text and then conversion, I think we will take it up in some other day. Even though it is 1 hour session or 1.5 hour session, we will definitely do it.
Perfect. Arijit wants to know, is sentiment analysis possible at this time using audio voice analysis, and if so, what models tech can be used for this?
There is a book by Charu Agarwal. Again, he is again from IIT Kanpur where I studied. He works in that IBM Watson Research Center, who developed most of the text analytics for the IBM Watson. His book I am giving. That is an e-book. What happens is for IIT alumni, that book is free. Since I happen to be from IIT Kanpur, I downloaded the book from my alumni site. Then I am giving that. Then one more book which we use it for text analytics, that is a John Wiley publishing book. The book I will give. Then few more PDF files and workflows also. Whatever demo I am showing, I will send the workflow along with the data file, and I will ask you to do some things different from what I am showing today. So like that you will become familiar with tool. Then a quick start guide for NIME also I will be mailing to all of you. It is only a 15-page or 20-page book which will help you to start off with NIME and the text analytics part of NIME. That's what I am planning, and whatever this PPT I am just showing now, I am going to send all of them to you.
Sure, sir, one last question.
Please,
I think we can move. Yadu Singh is asking, what is the algorithm best for sentiment analysis, and his follow-up question is the polarity score in sentiment analysis.
There are 2-3 algorithms. So one is based on machine learning. The second one is based on what we call a lexical analysis. These are the two broad categories of models. Whatever model you take in text analytics, they fall into one of them. So the lexical analysis doesn't need labeled samples. So what it means is, if you want to use machine learning type of models, you should have what we call the label type of data. Somebody has to manually, he has to read that 10,000 news or 6,000 news, whatever it is, and somewhere classify some of them into positive, negative. Sometimes this positive, negative alone do not give better accuracy of the polarity. Normally what happens is, it has to be grouped into 5 polarities, like highly negative, neutral, positive, and highly positive. At least the 8,000, 9,000 news has to be classified first. Then what will happen, we will train the machine, that I will show now, that machine learning part. Then an unknown news, if you give it to the machine will classify. The model used there is either a decision tree, or you can use all that ensemble learning, whatever is in the tree, and what we call the modifications of the tree, like XGBoost, all those things you can use and classify an unknown news into positive or negative. The second class of models, they do not need these label samples. So what we do, it is something like a dictionary lookup. We have a large number of corpus put into the dictionary, and they have classified into negative words and the positive words. So it takes a sentence, breaks into sentence, remove all that end, and or all these stop words, comma, full stop. This is called data cleaning. All that it does, preposition, conjunction, those type of words it will remove. It will take verbs, adjectives, adverbs, and nouns. That's what it filters first. It doesn't filter, you will have to filter it. I will show you how to do it. Then give it to a dictionary. Now with the dictionary, we compute the total positive words, and we compute the total negative words. The simplest thing is positive minus negative upon the total number of words in the corpus is a sentiment. If it is negative, it becomes a negative sentiment. If it becomes positive, it becomes a positive sentiment. That also I will show it in the demo, what we call the lexical analysis of doing. Even though it makes a mistake, it saves you a lot of time. What you do, use this unsupervised method first. Whatever it has correctly classified as positive news, okay, you call it positive sentiment. And whatever it has not corrected, probably manually you will have to level those news and use the machine learning again, because machine learning has a more accuracy compared to a dictionary lookup. And dictionaries, what happens is, sometimes you may not find that particular word in the dictionary, then it puts nothing, it puts a 0 or negative. For example, if you take my country financial news, SEBI find that company, there is no SEBI in the dictionary, because most of these dictionaries are not built in my country. So that SEBI doesn't know what to do, it may call it positive news, because it may remove that SEBI. Oh, he didn't understand, the regulator NSE find or something, NSE took some action, NSE identified some insider trading. Now NSE is not there in the library, again it makes a mistake. Take airlines. Jet Airways lines skidded on the runway. This is a very serious negative sentiment for airlines. Whereas if you use those default dictionaries, it will simply call it negative. No, this is more dangerous compared to some other negative polarity. Obviously, plane skidding on a runway, or how can you give every fellow then for some small mistake also, somebody says he robbed a bank or something. So the robbed a bank also gives negative. Jet Airways airlines also skid on the highway also gets negative. No. This is where the trouble comes in the lexical analysis. It will simply put you into two polarities. Whereas for most of the real life work, two polarities are not enough. That's where the machine learning comes into picture. Any other questions, Sudeep?
Sir, I think we can continue and we can take up the remaining questions,
Definitely.
later.
Definitely. And I will start with the demo. I will show them 9.
Yes,
And
please.
these two classifiers, what I told, the machine learning and the dictionary lookup. There is something called BERT, which is called the transfer learning. We don't have time to show it. Maybe in some other session I will do it. That gives a better accuracy. It is called bidirectional encoded representation of transformers. And there is something called GPT-3 and GPT-7. They are the latest models that have come. BERT is supported in 9. BERT supports 9. And your GPT-3 and GPT-7, what you call the transfer learning models, they are also supported in 9. But today's session I will not be able to cover. It will become another session altogether. Let us start with the basic. And many times even with basic thing, you can still do almost 70% to 75% of your work. It is not that totally we will have to put them in the dustbin. No, it's not required. So Sudeep, shall we break for a few minutes and
Yes,
assemble
I think right in the break.
Yes.
And then we can come back with the hands-on session.
Sure.
So I would request the attendees not to log out. We will start again exactly at 11 a.m. and
11:05.
sir, it's 10:50. So
Okay, 50 is it? Okay.
Yeah.
Good. Oh yes.
So we can come back at 11 then.
Recording stopped.
ഓപ്പൺ കോഴ്സ് അല്ല, ബേസിക് കമ്പ്യൂട്ടർ സ്കിൽസ് ക്ലാസ്സിൽ ആ UG എഴുതുന്നതാണ്. ടൈം എഴുതുക, സർട്ടിഫിക്കറ്റ് കോഴ്സ് ടൈം അറ്റൻഡൻസ് ഷീറ്റ് അല്ല മുകളിലില്ലേ കമ്പ്യൂട്ടർ കോഴ്സ് എന്നുള്ളതിൻ്റെ അവിടെ എൻഡിലേക്കായിരിക്കും കുറേ സ്പേസ് ഇട്ടിട്ട് അവിടെ ടൈം അല്ലെങ്കിൽ അറ്റൻഡൻസ് ഷീറ്റിൻ്റെ അതിൻ്റെ താഴെ അതേ സ്പേസിലായിരിക്കും ലാസ്റ്റ് വരെയായിരിക്കും. അഡ്ജസ്റ്റ് ആയിട്ടാണ് 3:30 to 4:30. മറ്റേ ഷീറ്റ് നടത്തിട്ടാണ് മുന്നിൽ സ്പേസ് കൊടുക്കും. അവിടെ കമ്പ്യൂട്ടർ ടെക്നോളജി വേണം, ഡിപ്പാർട്ട്മെന്റ് ഓഫ് കമ്പ്യൂട്ടർ സയൻസ് ഉണ്ട്. അതിൻ്റെ താഴെ ഒരു കോളം ലൈൻ ആഡ് ചെയ്യും. അത് മെർജ് ചെയ്തിട്ട് കമ്പ്യൂട്ടർ അത് സെക്കൻഡിലായി എഴുതിയതാണ്. ആദ്യം സെക്കൻഡ് മുതൽ ലാസ്റ്റ് വരെ മറിച്ച് സെക്കൻഡ് സെല്ല് മുതൽ അതിൻ്റെയാണ് കമ്പ്യൂട്ടർ ലിറ്ററസിൻ്റെ കോളം, സെക്കൻഡ് കോളം അതിൻ്റെ പുറത്ത് റൈറ്റിൽ മനസ്സിലായി. അവിടുന്ന് ലാസ്റ്റ് വരെ മറിച്ച് അത് തെറ്റി പഠിച്ചിട്ടപ്പം കണ്ടിട്ട് മാറി. സെക്കൻഡ് കോളം എടുത്ത് എന്നിട്ട് അവിടെ ഷിഫ്റ്റ് അടിക്കുക, എന്നിട്ട് ആരോ കീ വെച്ചിട്ട് റൈറ്റിലോട്ട് വിടും. ഷിഫ്റ്റ് ആരോ ഓക്കെ. ഞാൻ അറ്റൻഡൻസ് ഷീറ്റ് കുറച്ച് നടത്തിയിട്ട് ഇടയിലുള്ള സ്പേസ് ഒഴിവാക്കി. സർട്ടിഫിക്കറ്റ് അത് നടക്കില്ല. ശരി, അതങ്ങനെ അതെന്താ അറിയോ, ബാക്കിയുള്ള അതിനൊന്നും ഫസ്റ്റ് കോളം മെർജായില്ല. കമ്പ്യൂട്ടറും കണ്ടാ സീൻ്റെ അവിടെ മെർജായില്ലല്ലോ, ഇതിനും ആദ്യം മുതലേ മെർജായി. അപ്പൊ അത് മെർജാക്കണം. ഷിഫ്റ്റ് ലെഫ്റ്റ് ആരോ മുകളിൽ അതിൻ്റെ തൊട്ട് മേലെ ഇത് അവിടെ ഷിഫ്റ്റ് അടിക്കും, എന്നിട്ട് ലെഫ്റ്റ് ആരോ അടിക്കും. ഷിഫ്റ്റ് അങ്ങോട്ട് അത് റൈറ്റ് ആരോ അല്ലേ വിചാരിച്ചേ, ലെഫ്റ്റ് ആരോ അടിക്കും. ലെഫ്റ്റ് ആരോ എന്നിട്ട് മറിച്ച് കൊടുക്കും. ഓക്കെ, ചെയ്യും. 36 ഒരു 40 പോകട്ടോ അത് കഴിഞ്ഞാൽ
So let's get started.
Recording in progress.
എൻ്റെ ഫിസിക്സ് എക്സാം ആരാ വന്നേ
So can you hear me? Professor Chandrasekhar, can you hear me? This is Sudeep here. Professor Chandrasekhar, can you hear me? Hello? Sir, can you hear me?
Yes, yes.
Yeah, actually I was speaking on this file. Sir, we can get started, please.
Sure. They are able to see this screen?
Yes, I can.
This black patch, how do I move it? Below, is it? There is.
Actually, we don't see any black patch. You can minimize it. It must be a Zoom notification. You can minimize it. And I can see the 9 platform.
Okay.
Let's get started, sir.
Okay, okay. There is some talking Chandrasekhar, some black thing is coming here.
Actually, we cannot see it on our screens. It must be a Zoom notification. Either you can cross it out or minimize it.
Even if I minimize, it is coming. This one black patch is coming here.
Okay, can you cross it?
There is no cross here.
Okay, okay.
I think this screen they are able to see.
Yes, yes. Your screen is all clear, sir. We don't have any message.
Okay. I will. See, this is how the opening menu of 9 comes. So the 9 can be downloaded from their site, the www.9.com. The latest version is some 4.7 or something. What I have may be 4.6, that is little bit earlier version. To do text analytics, and our computer vision and image analytics, they recommend a minimum of 8 GB RAM. With some difficulty, some of these text analytics modules or the workflow, they run on the 4 GB machine, but I think if you have large volume of data, it doesn't work. It just hangs. The machine hangs. Those of you who have 4 GB RAM, you can try these workflows. I will mail some of these workflows with smaller data. And what you do is, there is something called 9.ini file. In that 9.ini file, by default, I think if it is a 4 GB RAM, roughly 1.5 GB is occupied by your OS, the processes which this window create, and all. What are you left with? Only 50%. That is roughly 2 is for the application. By default, it will allocate 1 or something. That you change it so that when NIME runs, it will allocate all the 2 GB. Maybe some of your background processes, it may close, or some unwanted web pages or those things it may close. It still works, but it works on the 8 GB RAM. 16 is what they recommend if you want to use that next level of text analytics models like BERT. There is something called encoder decoder models, that GPT-7, GPT-4, they will not run because it loads lot of libraries from your TensorFlow and Keras. So all of them has to be kept in the memory. So those level of models, the safe is 16 GB RAM. Otherwise it runs on the 8 text analytics. Text analytics still runs on 4 GB RAM. But what happens is, I think probably if you try to put that 2 lakh records or 3 lakh reviews and all, it may fail. Maybe up to 40,000, 50,000 records, it may still work. That 1 or 2 questions, you are telling, I will just answer them.
Sure, sir. In fact, now it's 10 questions I see.
5
more questions are getting added as we speak.
At least some part I will answer.
Okay.
Whatever is.
Okay. So a question from Ravi, who's asking, will it be giving labels? So I think it's referring to Ravi, your question is not clear. Maybe you can rephrase that. It's a comment from Venkat, who's saying, if the volume of the wrong data is more, don't you think even the social and sentiment analysis will be wrong?
Let me put the counter question. if the right or if the positives are new, machine will do the same thing. It will do everything positive. Now there is a way to get over. Let me tell you how to do it. If positives are very large, let us say you have 10,000 reviews, out of which 9,800 are positive and only 200 are negative. Any damn machine learning you build, it will definitely say it is positive. So what we do, there is something called undersampling and oversampling. Oversampling for a numeric data you can do. There is something called SMOT, what it stands for synthetic minority oversampling. So we can oversample a numeric data. Obviously text data you cannot oversample. So what you do, undersample the majority population. Now in your case what you do, undersample the negative news, merge it with the less number of positive news. That is one way to get over this.
Sure. So Sumit is asking, Sumit Kaur, how is content analysis different from text analytics?
Probably what may happen in the content analysis goes little bit one step further, where I told that summarization, reading that 30-page document and summarizing it to 1 page, 1.5 page, that also may come there. Whereas in the text analytics, yes, we normally convert the text to a sentiment and then leave it there. Normally, we do not go for document summarization, all those things.
Sure. And this is a question that Kanchan is asking, what is the applicability of sentiment analysis to fintech? I think we're going to cover that any which ways today.
Correct. We are going to cover that.
Yes. And Yadu Singh, how accurate is sentiment analysis?
That I told you, depending on the news and pre-processing.
Correct.
If you have pre-processed the data somewhere between 65 is the lower bound, maybe 75 to 80 we should get the accuracy. I have not seen where 100 or 99, I think. Even if some marketing man says, I think we should not go by that. Maybe it may be very balanced news. So that way you will get 100. But in a real life up to 80 you will get. 80 itself is good enough. Because what happens is your work is reduced to 20%, whichever is misclassified only you are going to look into them.
Sure. And Prajakta's question is, what is the best model for natural language generation?
There are some language models which converts from one to another. Some of them are machine learning, where you extract the keyword from that language Y and the corresponding dictionary you build up from X to Y. That is one method. That is what I spoke of with the lexical method. The second one is what I call the BERT, which I am not able to cover today. What happens is BERT reads entire sentences from one language, and there is something called an auto-encoder. Now that auto-encoder compresses the text, that is English. Now the corresponding text, to train the machine, you will have the corresponding text in the other language also. Now that also you encode, and it becomes an encoder to encoder mapping. This compressed text, in some way we compress it. Now there is another compressed text. Now the compressed text gets classified, and using a decoder I will write the original text back. We are not covering encoders, decoders today. It almost becomes then today class, I think. That's what will happen eventually.
Got it. Sir, Yadu is asking, what is clickstream analysis?
Clickstream is used by e-commerce sites. See, when you go to any site, what happens is you browse through their site. If you do not find whatever you are looking for, you exit from the site. Then they put what is called a recommendation. Whenever you are browsing, I will have to put an ad for you, because I know your preferences. If some new product has come or something, I will show it as an ad. So most of these clickstreams are used. Who are my customers, from which part of the country they are coming, and what is the type of purchases they are making, and using a recommendation engine. If some new product or something, if I put what is the probability he will click on that and then buy. And the another thing is, in all these e-commerce sites, you will have to bid for the advertising space. There is something called targeted price for acquisition, and you will have to bid. Then somewhere that Google has its own algorithm, then at what bid price you should do, so that your conversion happens to be the maxima. That is the clickstream.
Sure. Sir, I think this is the last question we should take, because I see more questions adding up. Last question is from Venkata Naidu, who's asking, is there any sentiment analysis models in local languages, which is non-English? And when we convert non-English to English, then do sentiment analysis go wrong because language translation is very weak?
No, there are two approaches. One is you don't convert to English and then do it. You are taking it to an intermediate language and converting. Some of them, Wariya, then Bengali. I was told Bengali is the highest spoken language in my country. And then comes Hindi, then comes Telugu, and then all others. That is how it has been done. IIIT Hyderabad is doing for the direct this text analytics for their Telugu language, and few are doing for Bengali also. Then another thing is that IISER is doing some work. IIT Kanpur itself does some work. I think Sudeep, you are the best person. There are a lot of startups working. Wariya, there are few startups who are trying to convert. Taking to intermediary, as what he is telling is correct. It creates more problems. They tried it in the middle, in the beginning. Somehow they did not get accuracy. So now what they are doing is the parser has to be written, the dictionary has to be written, then this data cleaning, like what I am showing for English, that entire thing has to be written for my country. Then unfortunately what is happening, English is the simplest language. It has only 26 letters. It doesn't have half letters and matras which we get in the Indian languages. So writing a parser and then doing the cleaning part is more tough here. And it takes, I think, that 16-bit encoding or 32-bit encoding for Indian languages, whereas all the English parsers, they use only 8-bit encoding. It is an ASCII text. So we cannot use the direct parser here because to encode my Indian language, it requires 16-bit at least. They don't have that upper bar, matras, half letters. No. None of them are there in English. The work is being done. It is being done, but I do not know whether it has come to a marketable type of product. Lot of work is going on. Even IIT Kharagpur is going. IIT Mumbai. I think Maharashtra, Marathi is done there. Varia, there are some startup companies who are doing, and even NASCOM itself has funded some of them.
That's right, sir. So we can continue with your demo.
Okay. So this is how it comes. As usual, your file, edit, view, mode, help, like that. So if you go to help, what happens is, if you want to know about KNIME platform, you just click it here. It gives you what is the version 4.5.1. KNIME stands for Constant Intelligent Minor Engine. That is what KNIME stands for. Originally it was developed in Germany. From the academics only it got developed. Then finally it got converted to a company. The headquarters of that company is in Zurich. It is in Switzerland. At that time, most of the menus and other things were in German language. They found if you want to make it to a production and take it outside their country, it has to become English. So that is how it got converted, and this company is located here. So this will tell you the version. Then what happened, this is how the menu, this is what we call the browser area. This is where we build the workflow. These are all what we call the nodes in KNIME. Now you see the advantage here. So each node will perform one specific work. I will show you how to build a workflow. And then the advantage of this workflow is, see, if you take a menu-based software like Excel or MS Word or something, every time you will have to go to that file, open, copy, graph, all those. These are called the menu-driven software. Whereas this is called a workflow software. And this workflow is written for one data. And then I will mail the workflow to you. What all you have to do is, you simply change the data file and the entire workflow runs. You do not have to do anything. So what happens, the application or development can be done in one place, and in the deployment phase it is very easy to use KNIME because there is no code writing, there is no debugging, nothing. Simply what you do, you go to that Excel. I will just show you here how easy it is. There is some Excel file we have read, supermarket dot whatever it is. Now tomorrow you say you have some other file, only browse it and then put it here, and the decision tree learner, you only do the right click and then execute that node, the whole node works. So they need not know what is all done here. They may not be experts also, they don't know all these things, nor we need them to know. So that way deploying the workflow to your production is very easy, and at the same time when this data changes, it will automatically change. And KNIME, there is a Tika parser in KNIME. If some time is there, I will show it to you. It can read some 30 different type of files. It can read PDF, CSV, HTML, MP3, MP4, AVI. This list goes on and on. And there is another important benefit in KNIME. What happens is, if you take a PDF file, if you take an annual report, there are certain tables and text. It is very difficult to extract only text from the PDF document. It is very tough. KNIME can extract, because to do a text analytics, I don't need general manager's photo in their annual report, all their bar graph, P graph, all those things. What do I need? What I need is the auditor statement, whether he is pointing something to a fraud there or probably something. So I don't want to read all these 350 positive news which all these management write. What I am interested is some other news. But that is a part of the text, numbers, pictures, all those are there in the PDF file. Using KNIME, I can extract only the text part. It will automatically remove all these tables and other things. That is a very powerful feature of the PDF, the Tika parser, which they have written in KNIME. So it can read some 40, including your Excel, CSV, VSV, all that. It can read. There is a graph-based software called Neo4j. It is a graph-based data mining type of tool. It can read that. So it has interfaces to SAS also. Some other big data, it can read Hadoop files. It can read data from Spark also. So those big data environment also it can read. There is a huge community in NIME, about 50,000 to 60,000. There is a NIME India group also, about 700 to 800. So what you do is, if you put your question there, somebody is going to respond. Normally you will get the response in some less, around 48 hours. If you take support from NIME, you will get the response in 2 hours or 3 hours. That support only is charged. That's all. For that they are charging because they will give you the response in 1 hour or 2 hours. But if you put it to community, yes, it is completely free. And these are the nodes in NIME, what I am showing. These are all what are called the nodes in NIME. So what you do is, the output of one node becomes an input to the second node. This is all of you may be familiar with the process flow. This is something like a process flow only. What we did was, we simulated the process flow in NIME. That's all it has happened here. And the other advantage is you can deploy this workflow to your company or an operational staff. For example, there may be marketing persons, there may be sales persons. Yesterday one file is there, today more data gets added. What all he has to do is, if the file name has changed, yes, he can change the file name and run it. And the other advantage of NIME is, in the same folder, for text analytics, you can put CSV file, you can put MS Word file, you can put PDF file, you can put HTML files. All of them can be put in a single folder, and he automatically identifies the type of file and reads. So you don't have to create separate, once reading HTML, once reading CSV, once reading XLSS, and once reading, no, it's not required. And even zip files, it will automatically unzip and then read it. So it is a very powerful reader in NIME. That is the other feature. I may not have time to show this Tika parser here, but definitely I will mail a workflow to all of you. You can play with that. I will give you some PDF files and other things in a single folder. I will just see how it works. Edit. There is nothing to edit. I will show you. I will open one blank workflow and then just show it to how easy to build a workflow. Then I don't have time to write the workflow. I will read some predefined workflows and then show the demo to you. So what you do, come to file, come to this, click new. So I am building a new workflow. Click this new workflow. There is a workflow group. Means what happens if you are working in a group, there are some 15 to 20 there are 15 to 20 staff or employees working in that group. You can share the workflows. That is your group. So what happens is, all the workflows which XYZ different analysts, programmers, developers are all doing, they can be shared. That is one thing. And if you have 30 workflows in a workflow group, you can tell them 10 only is what can be edited, another 5 cannot be edited unless your supervisor or somebody gives a privilege to edit. This is what happens in the operation. We don't want somebody to come and edit an operational workflow. It becomes a big issue. So you can, depending on the user group and the protection, certain workflow within the group also can be protected. So if you want to create a new workflow, put this new workflow, put to next. Now it asks in which of these folders this workflow has to be created. For your demo I am putting local. This is how the default when you install NIME it comes. And if you see in the left hand side, I have created some more folders like Arima. All the Arima is a forecasting technique. All the workflows related to Arima I have put here. And there is something called BIM. I was teaching this course at Bharatidasan Institute of Management. Some of those workflows I have put here. All the deep learning workflows I have put here. Now today I will read some of them from this NASCOM class. For the NASCOM class I have put some workflows. So if you click here, it will show you all the workflows that are, these are the folders. Local is a default folder. You put this finish. Now it opens a blank workflow. Now here you can move, there is something called the node repository you are seeing here. These are all the different nodes. That node you will have to move it here. I will just move one or two nodes here. Come to IO. Click this IO. Then there is something called read. Click this read. You have all the readers. Excel reader. This is some general file reader like from Notepad or other things, which is not a CSV type of file you can read here. There is something called ERFF reader. These are some model readers. CSV reader. Line by line you can read a text. So if your document has some 40 lines or 50 lines, that is, it stops with a full stop. Now you want to read sentence by sentence, not the total document. So if you use a line reader, it will somehow identify that line boundary, and then if your A4 page contains about 30 sentences, it will separate these 30 sentences, because sometimes I will have to assign a sentiment for each sentence. I don't want to assign a sentiment for the entire document, because that may become somewhat overall, it may not be that good. Each sentence or a group of sentences, I want to assign a sentiment. I don't know how you start doing all this in Python. Maybe some of you can see the complexity now. How will you do this in Python? I don't know. Or you may have to write lot of code or use some library, again write your code. No, it is tough part. How do you extract text alone from tables from a Python code? One of you give a try. You will take 1 month now. You will not do it. So that is automatically a PMML is a model reader. What happens is the model part only if I develop, and if you have new data, instead of giving the entire workflow, what I will do is I will give this PMML is a model. You download the model and give your data alone, so that the other party doesn't have to know what are all the workflow has gone into the model. So some type of protection it gives for you, because you are not exposing the entire workflow here. You are giving only the model. This is something like giving an exe file, the counter example, where I will not give you the source code, I will give you only the exe. It is something like counterpart of that. All these readers are there. See the n number of readers. Write is also there. These are the other things. All of you understood? All these file, folder, all that it can read. Click this one, you get manipulation. Then if you want to manipulate the column, click these columns. All these are there. And within that filter, some column filter. So if you want to use a column filter, what you do, you move the column filter here. Now let us say something you have read as an Excel file or a CSV file, move the Excel reader here. Now Excel reader would have read about 30 columns. What you are interested is only 10 out of them. What you do, the output of this Excel reader, you join it here. I'm just showing you how simple it is to make our workflow. So okay, we have removed some columns. Then to build a model, normally we split the data into some training part and the testing part. So what we do is we build the data using the training set, and we put it on the test set. So there is a node. This node, there are about, if you load all the extensions of 9, including image analytics, text, etc., etc., it comes to roughly about 2,500 nodes. That means 2,500 processes it can do for you. Each node is roughly does a process. So searching will become maybe difficult for you. So what I will do is I will put some PAR or something. So it is a partitioning node. You move the partitioning node here. So join this here. Then some settings will be there. Go to this configure. It will ask you how much I will build. Is it relative 70% or absolute? Shall I take it from the top? Shall I do it randomly? All this, you click one of them, click OK. You have set the node. This is how we build the workflow. So if you want to come back, remove this search word, you go back to this full dictionary like this. Then come to analytics. I will just show you sample nodes. Then I will show you the workflow itself. I am just telling, I think as long as you know how to use a mouse, you will be able to use 9. Forget all these other library, code git, etc. What happens is, to avoid these version conflicts, NIME advises you build separate environmental variables. So using these environmental variables, you can put the correct version of these Python libraries there. NumPy is equal to 1.1.0, TensorFlow is equal to 2.2.0, whereas your other application may require some other version. Then what happens is this 9 creates a conflict now, because your some other application may need Tensor 2.3, whereas this fellow may need 2. So every time you can't go to Conda, uninstall, install, it becomes a major work, and how do you put it in production? No, it becomes a big mess. You won't be able to do it. So we can create environmental variables. For each group of workflows, what you do is you select that environmental variable, so that even if you put a higher version of NumPy or TensorFlow or Keras or whatever it is, Scikit-learn, Pandas, Gindas, this will not get affected. Because this environmental variable takes only those type of libraries into picture, so that way model is stable. Even if somebody updates some part, and then when you load from pip or Conda, by default it loads the latest version, unless you put that double equals and then put equal to something. No, it will not load. Then this may work only on an earlier version, then the workflow stops now. So to create these type of conflicts, you can create what is called an environmental variable, and when you use that application, select that environmental variable, so that we don't end up with these version conflicts. So come to these analytics, there are a lot of things here. We will show you mining. These are all basic statistics, you don't worry. Mining. Then you are all this base, clustering, rule induction, neural network, decision tree. See the number, huge it is. Anything you can do on the earth. Decision tree, ensemble, miscellaneous classifier, ensemble learning, association, discriminant, polynomial, logistic regression, multi-dimension scaling, principal component analysis is your PCA. PMML is model that will support vector machine, is another classifier, it is a non-linear classifier. Feature selection, it will automatically select the features. So if you give 30 features, you say 8 important is what I want, he will select the 8. You don't write single line of code now. We are not writing any coding at all now. Optimization, all your minimization, maximization, scoring, that is your credit scoring, that default scoring and other thing comes in the scoring node. So the whole ensemble is here. I will select one and then just show you how easy it is to develop a workflow here. Take this decision tree. Click this. Decision tree learner is what it will learn. The decision tree predictor is used for prediction. So what to do? Move the decision tree learner here. So for the training data, I will have to join this here. Now the tree will run. I will show it in an actual data. I am just showing how the workflow will be built. Now after we want to do a prediction, move the prediction node here. And just move them. You can move the nodes like this. There is a beautifying node also. It will arrange all these things for you eventually. Now move this here. Now to do a prediction, I will have to tell what model it is. So drag it here and then join. That means the model parameters are going here. The data comes from here. So what you do is join this data line here. That is how it is. Now it will do the prediction. So to run any node, you click the right button of the node and then ask it to execute. Since I have not configured the node, this execute has become gray. The moment you do it, you will have to execute. Our workflow is running, even if this has some 200 nodes, automatically you go to the last node, click the right hand button and then just execute. So automatically all the previous dependent nodes will automatically run. So this is another, we are not going each time to open menu, file, click, no, we are not doing. They are menu driven software and is a workflow based software. And most of the operational, what do we call this latest software, they come with the workflow. Whether you take head2o.ai or RapidMiner or 9, and there is something called BigML or something, that is another competing product with 9, they are all workflow based. We develop a workflow. There is nothing but to debug here. The moment workflow start working, you convert to a PMML type of file. deploy it in your operation, he will simply change the data file. If I want to do it for another new data, what all you will have to do is configure, instead of this file you select some other file and come to the last node, click the right hand button and then execute. The entire workflow runs. Any doubt so far, our Sudeep?
So there are, I mean, no specific doubts here, but with related to the platform, I think Mahesh is asking, is there a node for hyper tuning of parameters using grid search?
It is there. Available. It is available in the deep learning. There is something called a deep learning here. In that, all of them will come, not in this normal analytics. This is our one level down. All those nodes what he is asking, that is called the hyperparameter tuning. How many neurons you will have to put, the dropout rate, learning rate, the momentum rate, L1 optimization, there are a host set of parameters, how many layers, that is available, not in this. There are separate nodes for that. There is a deep learning nodes here. Under that they will come, but it is available.
Sure. So question from Prasad and Jayashree. Question is, a data set, what data set have you used in the decision tree predictor, and is there any limitations on data size, data set size?
No, there is no limitation as far as 9 is concerned. I was told even up to records up to 1 crore have been deployed in prediction, particularly your loan sanctions, and then identifying the what we call the suspicious transactions in a financial network in real time. So what I told is even they have tried with 1 crore record.
Sure, sure.
Good number. Good number.
Okay, okay. And to Jayashree's question, what data set have you used in the decision tree predictor?
I will show you. This is a dummy thing I show. I will show you the actual flow. I just wanted to show them how it is easy to build our flow. There is something called that supermarket data set. That's what I will show them now.
Got it, got it. And Karthik has 2 questions. How are you handling null values outliers, and how do we do standardization?
There are 3-4 methods of standardization. That null value, there are missing value filling node here. You have 2-3 methods, either based on the previous average, moving window average, local regression, k-means. There are 2-3 methods he allows you to fill the missing value. So that node is already there. You will have to select what type of missing value algorithm or logic you want to do. So what normally happens is you select 3 of them or 2 of them, compute what is called the mean square error between those that is missing and non-missing. First what you do is remove those missing values and then take some average like a moving window 3-point or 5-point average and put it. The second one is do a small regression, some 4 points behind and 5 points after, a local regression, and then predict that value using our classical y is equal to mx plus c type of thing. Otherwise, you fit a first order curve or a second order curve. That missing data won't be there. You remove it and then put a curve. It will give you equation to that curve. Something like y is equal to a to the power of bx, or y is equal to a plus bx plus cx square. Now this ABC we get using non-missing data. Then that missing data, you know the record. So the record number is the one input there. X-axis is your record. Y-axis is the value. Now you put 34 there in that. Now you get the value for 34. That node is there in this. It is quite powerful.
Sure, and I think the answer to this is yes, and that's a question from Shubhadeep who's asking, is there any way to connect to data source like SQL or NoSQL databases?
It is there, it is MongoDB, NoSQL, Pedigree, all that is available.
Okay, and can we configure multiple files or multiple sheets under the same file?
Yes, multiple worksheet, multiple workbooks. Workbook can be combined with MS Word file, PDF file. That's what I told them.
Okay, and there is a question from Venkat. Is it possible to analyze the audio pronunciation?
Yes, it is available.
Perfect. Ravi is asking.
Only thing is, I am not able to show all of them today. That is my
Absolutely.
concern.
Absolutely. Ravi is asking, we have to use clean data set only, or it will be okay with the raw data set?
Ra, he has given some cleaning methods. So you can clean those data using those things. That's what I told you, missing value cleaning, there is a separate node. So
Okay.
it has some different methods of filling. So we can use them. Or if your data size is very large, we can drop them if only 1% is missing. But unfortunately what happens, if it is a time series data, you can't do it. See, it misses the sequence. So if it is a time series data, if you are using any time series type of modeling here, compulsorily you will have to fill it.
Got it. I see, 3 questions from Virendra Kumar, who is asking, may I know which industry this product can be used? And he is working in an IT security product and services company. And in which sector we can use this product? So I think he's referring to 9.
It is using in marketing, it is used in finance, it is used in preventive maintenance of the machine when the machine is likely to fail. It can interface with the IoT also. So security, any specific application, I don't know. Maybe where it is used in the financial sector to identify loan defaulters, which company is likely to default, both at the retail loan level and also at the corporate loan level, and the rating transition of the companies. Today, the fixed deposit of the company is AAA. Is it likely to stay AA in the next 3 months window or 6 months window? And identifying suspicious transactions in real time in the financial transactions. That is what I have heard of. Marketing also it is used. What product, recommendation engine, what I spoke to you, so what products has to be recommended. There is a market basket analysis which says that what are the common items that are probably purchased together, and if I reduce the price of one product, how the bundled revenue will change. And in forecasting, demand planning it is used. All your inventory management, warehouse management, what to ship where, logistic part is used. And it has an optimization also, route optimization is here.
Sure. So there are more questions coming in.
I think I will continue with this, otherwise this
Yes.
is going to stop now.
I would.
It is very good, lot of so much questions and interest it generated. It is really nice for me to hear these questions, and wherever I am able to clarify, I have tried to clarify them.
Sure.
So I will come to this NASCOM class. So I have put some 7-8 workflows, all of them I will show it to you. There is one simple workflow called text mining demo, the Superstore decision tree. I will just show them. So what you do is you double click on that, it loads the workflow. Do you want to update right now? I don't want to update, I will put it here. Now here I have read that Superstore sales data. This is a real life data. It is available in Kaggle. So I have used the Excel reader. So what I will do, I will reset the node first, so that I will run the node again. Now each node, when you right click it, some configuration, some inputs has to be given for that node. So what you do is first you configure the node, then you execute the node. Because without configuring, it doesn't know what you want to do in this node, because there are many features in a given node, So at least you will have to tell the software what you want to do. You click this configure, it will ask me where is my input file. It is here. C:9 workflow sample data sample superstore.xls. That is the input file. Now it gives you a preview also. Somewhere below, it shows you how the data looks. Even before actually reading, order ID, order date, ship mode, customer ID, segment, country, city, state, postal code. This is the entire data. This data I will read it. That means this is the file I am going to read. Now here he has given, you see here, XLS reader I have taken. Either you can read from specific rows or some specific column, and then here he is asking read the entire data sheet or some part, and then here there is another thing I will show you here. You want to read it from local file system, or you can read it from the URL itself. See, there is something called custom URL here. So if that worksheet is stored in a web page or something, you can directly read it from the URL. That is this thing. And mount point is on the cloud, you can read. That is that mount. Some space will be mounted on the cloud. You can read it from the cloud also. I am reading it from the local file system. And this one, table contains the column names in the first row. If it does not contain the column name, you can put it. Then what happens, you can read some specific areas in the worksheet. Or you can read it from a folder itself. Local file system, you can read it from a folder. All the worksheet you can read. That's what he has put here. Some empty rows, if you want, you can skip. All that is here. Skip empty rows, all that. This is how the preview looks. So you close this. Now what you do, I have selected the input. Now again, you right click it and execute this node. Now actually it is read. Earlier it was not read. I have simply connected to an input source. The data is not actually read. Now you click this execute. Now you see here slowly this blue bar is coming, and if there are no errors, that amber light changes to green. Now if the node does not execute, this becomes red. So then you will get a small error also here at the bottom. So what happens, the node will be amber when you before you give that configure. After configure it will remain yellow. These are traffic light signals. So when you execute it, if everything is executed properly, this becomes green. If it is not executed properly, this becomes red. That is the convention here, so we have read it. Now come to the sorter. So I will just show you configure. What all I am showing is the order date. I am sorting it in the ascending order, because right now it is not in the ascending order. We will sort it. Here I will show you how it has been read. Output table, that is the table. So it says there are 9,994 rows. That is the input data. There are 20 columns here. If you click on the column, he will show you what is numeric column, what is string, like that. It will also tell you what is the lower bound and the upper bound. So if you come to the state, so in state you have this Kentucky, California, this is a non-numeric number. So he will give you the different attributes sitting in this number. If it is a numeric data, he gives you what is the minimum, what is the maximum, like that. This you will get. And if it is a date, what is the lower bound and the upper bound, both for the order date as well as the ship date. So string means it is a non-numeric data, number means it is a numeric data, date is a date field. So all the summary you will get here only. File and then close it. Now sorting again, I have put ascending. Just execute the node, this becomes green. That means the data is sorted. Now certain rows only I am taking. Here is a filter. So extract date and time field. So if you click it here, you can select only between two dates. See here. Now what I am doing, it is a daily data. The daily data I am aggregating it to weeks. Because probably I would like to do a demand forecasting for some weeks, or build a decision tree. What is the average sales during a week or a quarter? It is not forecasting. I am not running a forecasting model. Just an overall dashboard which tells weekly which state is what sales, like that. So I am aggregating the data to week, month and the quarter. Your original data is in daily sales. So you are aggregating. That is this node. This is okay. What you do, execute this node. Now it will be weeks only. Just open this node, put the output table. It will be here. See here. Quarter 2, 3, 2, 3, and then here quarter, month and week is there. 2, 3, 4, 4, 2, 3, 2, 3, like this. Within the quarter, week. I think it is 1 year of data. So this will go up to 52 now, roughly. 52 weeks. I have taken only 1 year data. Otherwise it was very huge. It will take lot of time. Somewhere like 52 will be there in this. So it has separated. So what we have done is we have aggregated the data here in this node. Just I will show you. There is something called a group by node. So what I am doing, there is something like your pivotal table of Excel. I am just aggregating the data to see how it looks. So there is a group by node here. That node you move it here. The output of this you join here. Let me execute this node. It will show you some summary here. Group table. It is here. Month is 1. Week is 1. State is New York. region is east, the category is office supply, the total sales. This is something like your pivotal table only. I just aggregated the data here. This is not text analytics. I am just showing you how easy it is to build a workflow. Text analytics workflow I will show you later. After this, I will show you that one. We can plot those sales. You just execute and then open the view. This is how the sales are looking. You can change all that font, color, labeling, all that features are here. This is how your sales look like. Now what I am doing, I am somehow trying to build a decision tree where I would like to know I will take sales as the dependent variable, your others, some of them like your region, product code as independent variables. Let us see which part of the country, which products are more or something like that. That is what it is. So here I am partitioning that. Come to configure. So what I am doing, 80% I am taking randomly to build the model, draw randomly, and 20% of the data we will use it to validate the model. How good is the built model? Is the classic way how we build any machine learning model. Some will take 75-25, sometimes we take 80-20. Normally below 70 we do not take, because below 70 if you take, machine would not have seen all the type of samples. Something would have gone as an unseen sample, the error will be very high. As a rough rule of thumb, you take 75-25. If you have 100 records in your data set, 75 let us use it to build the model and 25 we will validate, so that we are sure how the model is working. This is our simple regression tree learner. I will just show you here. I will just configure this. I will show you some configuration. These are the input I am using. Month, week, state, region, and then category. This is my input. My target is the sales. So if you click here, all of them will come. So my thing is sales. So you keep the sales here. And then these are my independent variables. Now the advantage of decision tree over regression is, what happens is in regression, some of these variables have to be independent, all those classes are there, whereas in decision tree it's not required. It doesn't read any, I don't know, something is getting stuck here. I think I will log again. Let me see. Even this restart is not coming. Something is coming. Somebody talking. Some message I am getting in between this.
Sir, anyways, time for the next break. It's 11:52. Right? We can always, take a break and come back in 10.
Correct. I will just see whether something is coming here. Some message has been getting.
Sure. So maybe you can stop sharing and we can do that once again.
Right. Yes.
So
And I will show,
everybody-
after this, I will show the text analytics workflow after this. This is simple number where I am going to show them how a gradient boosted tree works better compared to a simple regression tree. That's why I have put both the nodes here. I just want to show some output, how drastically your model, if you do not select a proper model, what is the variation in accuracy like that. That's why I am showing both of them here.
Sure. So I would request everybody to stay logged in and come back by 12.
Sure.
Exactly at 12 we'll get started.
Sure.
Recording stopped.
ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಇದೆ, ಅದೇನೋ ಮಧ್ಯ ಇದಾಯ್ತು, ಒಂದು 10 minutes.
എപ്പോഴാണോ വരുന്നത്? 12 മണിക്ക്. എന്നാൽ ഞാൻ അടുത്ത ആഴ്ച അരമണിക്കൂർ എന്താ? എത്ര പേരുണ്ട് നിങ്ങൾ?
15 CS-ന് ഈ ഒരു ഇത് മാത്രമേ ഓഫീസ് ഓട്ടോമേഷൻ മാത്രമേ ഓപ്ഷൻ
അവർ ഫോളോ ചെയ്യുക.
So we can get started, and just letting you know that we have Sumit, Anupama and Aditya also logged in. Sir, can you hear me? Sir, can you hear me?
Hello? Oh yes, oh yes. The screen they are able to see. Hello?
Sir, we are able to see the screen.
Very good.
Okay, just want to tell you that the Capco team has also joined in. I have Anupama, Sumit and
Very
Aditya.
good. Very good.
Alright, so
Very good.
I'm starting with the recording. We can get started now.
Any more questions are there?
Quite a few. I have 15 of them.
Oh, then I will continue this for a while and then
Sure.
I will name. So up to this I have told them.
Recording in progress.
So we build the simple regression tree learner. Then there are two types of trees I have built. One is the regression, another one is the gradient boost. Since I don't have time, I will just show you the output now. You just see the tree output here. The predicted output, that means the partition part, you feed it here. The model data comes here. So this will do the prediction. You just see, if you use a simple tree, you just watch here. Now California, if you take west is the region office supply. So your predicted sales is 1907 and your actual is 13461. And here if you take it is 490 and it is some 13462 and all. There is a lot of error here. So obviously for this data, the simple decision tree has not worked. So we will close this one. Now only one tree I have built, and this is what is called the gradient boosted trees. Instead of building one tree, we build multiple trees. So what we do is we take some type of an average prediction. So that is called gradient boosted trees. So the output of this I will show you. See here it is very close, 22,576, 22,481, 27,262, 26,837, 24,650, it is a very good prediction. So somehow we don't have a theoretical proof for any model building work. There is no guarantee which model works. Normally what happens is we try 3, 4, 5 different type of models over a period of time and see the stability of the model, then only it moves to the production. There is no theoretical proof which says that looking at the data that is the model. No, there is no such thing. There may be some automatic AI system so it tries to do, but that all depends what type of, who is that expert and what rules were put there. If they are not put properly, no, obviously this will not work. I just showed this demo to you to tell that how easy it is to build a workflow like that. That was the purpose of this. Now I will show you one text mining workflow, which is our main topic of the day. I will just open the workflow. How to close this one? I will just show it here. Now there is a review here. I think that is from Amazon or Flipkart. It is an Excel file. So I will read the data here. The process flow of this I will explain first. Otherwise I may not have time to do the entire, to run each node by node. It takes some time. At some other point in time we can definitely do it. What you do, you read the Excel data or your CSV data or your PDF file, whatever it is. Where the menu of text analytics comes, I will show you in 9. There is something called other data types. You click this other data type, and text analytics is an extension of 9. So automatically when you download 9, text analytics or image analytics, your deep learning and all will not automatically get loaded. So how to load those extensions is, click this file, come to install 9 extensions, you click here. Now it will automatically show you what extensions have been installed and what extensions have not been installed. So now these are all not installed on my machine. So if you want to see what is installed, click this, what is already installed, that is what here. All these extensions I have installed here. All these TensorFlow, Keras, these are all your deep learning extensions. These are all your these are the, you can integrate 9 with the Head2O.ai. They are the integration of this Head2O.ai. This is another AIML tool here. Image processing, all the modules are here. Somebody was asking, how do we convert text to image and all. Some of these modules are here. All these are text processing. Text processing, deep learning is also there, so that you can use text processing with that BERT and GPT-3 type of models. That is what here. So Arabic, Chinese, French, German, French and Turkish, these are the languages which our 9 supports. So we don't have Indian languages. Once I asked them, why don't you write, then he said, sir, what is it, India itself exports software, for us it is better. You develop in your country, you give it to us, we will market it. That is the statement they made. So all these are your text processing extension. This Twitter, reading data from Twitter and all is come here. These are your XML language. XGBoost is your XGBoost ADA integration. The Neo4j is a graph-based data mining tool. That is here. All these Redfield BERT is what you use if you want to use this BERT model for classification of text. It is an advanced model. It gives you very high accuracy compared to your other nodes. What I have not installed is your other things. Like your big data integration, all those I have not installed them. That is what it is. That is what is not installed. So this is how it is. You will have to install this. These I have not installed. Community extension, then Camo Informatics, community extension of image processing I have not installed. I have installed the other one. Lab extensions and these big data extensions. Here is where you read data from Spark, you read data from Hadoop, you read data from large cloud-based platforms. They are all here. That I have not put it because it eats away a lot of disk space. That's why I have not done it. So what you do, you click this text processing. All the nodes that are required for text processing is there. You read the text. All these IO nodes are there. He has given so many RSS feed. Reader is when you want to read news in real time. This is the reader. There is a PDF reader. You can read the PDF files, extract all your text only and throw out all those images. All this is here. There is something called a Tika parser. This Tika parser can read large number of files. I will just show it here. Because I am not using Tika parser, it is a simple Excel file. It can read Excel files also. So what you do is configure the parser. Now you see the different type of files here. See, these are all the extensions it can read. See the number. Virtually I think anything on earth it will read now. 30-40 different type of files. What more you need? Some XDAD, XW, examples. So many extensions are there. See the extensions. All these files mixed also within a single folder, and even in subfolders it can read. MP3, AVI, all these are audio files. Can read. DBase 3, DBase 2, all that is here. So it can read here. It can read from a single search recursively. If you tick it, automatically automatically it will read the folders and subfolders. Since it is a simple Excel file I am reading, so I am not using this Tika parser. So for your show only I just showed it. I will delete the node. Now if you want to delete some node, some connection, you click the right hand button of the nose, you click this delete. It will say, do you want to delete one connection? You put okay, that connection is gone. This is how you want to delete some lines in the workflow. I will rejoin them again. No, something is happening. I am not able to identify what is happening.
Sir, anything which I can help?
No, it came. It has come.
Okay.
So I have read the Excel file. I will show you the data file. In the configure you put the file. This is where it is. Sample review data does Excel access. It is the Excel file. So below I will show you some sample data here. The row ID age of the customer who wrote the review. The title is here. The review text is here. That is the text part from the e-commerce site. And the rating he has given that 1, 2, 3, 4, 5. The department in which that particular product was purchased. Then the sentiment. So what we have done is I have converted 3 and above to positive sentiment, and 2 and below I have converted to negative sentiment. That's what you are seeing here. We will execute the node. The node has been executed. So the file table is here. This is it has read into 9 now. Now what happens, since 9 reads different type of files, there is something called a string to document. We will come to this afterwards. Here in the column filter, I am keeping only 2 columns. These are the large number of columns we read from the Excel file. For my analysis, review text and sentiment is important for me. I am not interested in that age, all those things. Maybe at some other point in time you can merge also. For your demo purposes, I have taken only review text and the sentiment. Now we will execute this node. So you will get only 2 parts now. Out of all the table, you get only 2 now. This is the review text and that is the sentiment here. Only 2 columns I have kept. That is by your column filter. There is a group by node also. So just I want to know how many positive and negative news is there. You come here. So there are 809 negative reviews in this data set. There are 2,557 positive reviews. Just I did a group by. So it is something like a pivotal table. I roughly get the idea whether it is 1:3 or 1:4. Normally 1:1 is very ideal to build a model. Since samples are small, up to 2 or 3 we can try. So even if I build this basic decision tree model in this, accuracy will not be high because it is an imbalanced sample. So I will leave it as an exercise for I will mail this workflow. So what you do, it is like this. Obviously this classification will be very low. What you do out of these 2,557 positive news, you take only 50% of that. That is roughly you take about 1,300 positive news, merge it with these 809 negative news, run my workflow again. That means you don't have to change my entire workflow. Only somewhere here, you another 1 or 2 nodes you will have to add, and that automatically it makes that modification without touching any one of the further nodes here. I will send this workflow to you. I will tell you what all you will have to do. Anyway, I will show you the accuracy. It is very poor. I know it. And that's because this is an imbalance set. Something like 800 to 2557. So what I am trying to tell you is take about 30,000 positive reviews from this, merge it with this 809, repeat the workflow. You have to do only 1 or 2 additional nodes here to remove that row filter like that. That's all. Then merge the rows. Then all this will run again. You are not making any changes. This is your input. Then we do something called the enrichment for the text. click this enrichment node, there is the tagging. So what happens is your text has to be broken, that blank space has to be identified, then the words boundary has to be identified. That is done here. You have so many taggers here. I will use this Stanford NLP English parser. That's what it is. So when you click this, automatically the help comes here. Suppose you know what this dictionary tagger is doing. Click this dictionary tagger. Here that help is coming here. What is the dictionary tagger? Automatically your right hand window gives the text. Suppose you know what is this POS tagger. Click this POS tagger. He gives you there. That's what it is. Then NIME itself has lot of these pre-built workflows. There are about I think 15,000 or 16,000 workflows which are available on the NIME server. They have categorized into deep learning, then missing value information, clustering, all that. It is grouped. So you can download those workflows. They are all free. Most of the time you may have to change some parameters in that data file. Simply execute the workflow, it works. I think any prototype I can build in 3 hours without knowing a Python or without knowing R or without knowing any damn programming language. I can build the model. It is so user friendly. That's what it is. There are large number of workflows. There is a community group in NIME. They have also done this. Then there is something called a transformation. So it will convert the document to vector. This I will explain as I come here in the workflow. These are all the text mining nodes of NIME. Then here pre-processing is there. All that case converter, then n character filter, number filter, removing the punctuation, all that is here. This is a very marathon work if you start doing in a programming language. No, this will become too tough. A regular expression filter, punctuation, stemming. So what happens is it converts that word to a base form, something like goes, going, gone, etc. will go to go. Because why should I store all these words? And then what happens is when I built the bag of words, they will all become different words. There is no meaning. Go, run, runs, ran, running. All these it stems. That is called stemmer. There are 2 stemmers he has provided. One is called the Stowball stemmer. Another one is the Stanford stemmer. All that will be there. So if you use a programming language, all of them you will have to do. No. All the libraries have to be loaded. All that has to be done. It will not work like that. Then the frequency, this is one type, like we show a bar graph or a P graph or a line graph for numeric data. These frequencies is what we see. Frequency filter is there. Then there is something called the miscellaneous here. Categories. These are all the text mining nodes in NIME. I am not using all the mines. I just see the capability of the tool. Virtually any damn thing it can do on the earth. I think the ratio must be 3:10 or 1:10 or 1:15. If you write the same code in Python or any other programming language like Java, it may take 15 to 20 hours. That prototype, I will build it in 1 hour or 1.5 hours in NIME. And you don't have to learn any programming language for this. It is not required. You don't need any programming language. Now there is something called string to document. So what we do, since different type of files we can read, it converts to an internal format. That is what we call string to document. So what it does is it converts to some internal format of NIME. So I will just execute and then show you the output. This is my original data. That review text is my original data. This is original. This is that internally formatted data of NIME, and he will use this for all the future nodes. Because one may be PDF file, next may be Word file, next may be some CSV file, and also what all he has done is, this is something like a standardized file format within NIME. So whatever type of data you read within NIME, he converts to this format, and all the text processing nodes will work on this data, not on your original data. So this is that file. You can see it. So I will close this one. Now this is what we call the pre-processing. I have converted to a document. Now from document, all these text processing nodes will work on the document format. They do not work on your original format of 9. So here what I am doing, I am converting all these uppercase to one case. Because what happens is sometimes your first letter will be capital, other letters will be small. So to remove it, I will do the case converter. We remove all these punctuation marks in the text, because for text analytics, I don't need all these punctuation mark. So we remove all these punctuations, and there are some characters like a, and the 2 characters, 3 characters, etc. There is a n character filter. We remove characters less than 3. Because don't remove characters more than 3. Unfortunately, what happens, this not is a 3-letter word, and this not reverses the polarity. See, if you remove more than 3, not gets removed and it will become good, whereas actually the text is not good. So be careful here, because it is a negative polarity, it changes. Always remove words less than 3. 3 and above don't remove, because unfortunately this not happens to be a 3-character word and it changes the polarity. This is one common mistake many times even my students will do in this text analytics class, because I have taught this text analytics to 2 IITs, 3 IIMs, my own institute, and then Bharatidasan Institute of Management, Narsi Monji. So that is a common mistake they do. So don't do that one. Don't remove this not, because the moment you put 3, it becomes 3 and less. He removes the 3, and unfortunately this not gets removed. This is a common mistake, and your whole classification goes for a toss, because that not got removed, that is a negative word. So always remove the words less than 3 characters, not more than 3. Numbers do not carry much meaning in text analytics. We try to remove those numbers here. That is the number filter I have put here. How do I move it? I will just take it up somewhere. This taskbar I am missing. So 3-character filter, number filter I have removed. There are stop words like and, a, these are some stop words. We will remove all the stop words because they are not required for me. Then we attach a part of speech to each word in the text. That is what we call the POS tagger here. Whether it is a noun, adverb, adjective, conjunction, modifier, etc., etc. I don't know. Lot of you may be knowing English. Otherwise, that language little bit you know about it. I don't know. Out of curiosity, I will ask one question to all the participants. All of you know noun, adverb, adjective, etc., etc. What is a transitive verb? So some language part, be careful to when you do this text processing here. There is something called a transitive verb and there is something called an intransitive verb. So what is the difference between a verb and a transitive verb? Between a verb and an intransitive verb, because unknowingly I don't want to remove those people. Then whole text classification goes for a toss. That's why. So we attach the part of speech for all of them. I will run some of the notes and then show it to you now. So these are the notes. Then sometimes you want to pick only verb, adverb, noun, those type of thing. I don't want preposition, conjunction, those type of thing I don't want. That is the tag filter. So we tag and remove some type of tags which are not required. Then we create what is called a bag of words. From here only your text analytics will start. So we removed all the characters less than 2 words. Punctuations have been removed. Then some part of speech we have attached, and certain part of speech only we have kept for our analysis. This is the pre-processing for text. All that semicolon, full stop, apostrophe, all that we have removed all that, because for me they do not contribute. So that is what it is. So I will just show 1 or 2 notes. I don't have time today, so I will just show 1 or 2 and then maybe final output I will show it to you. Today I will not be able to show another 2 classifier because my colleagues are waiting to show some more on this. Maybe some other point in time I will show it to you. Probably I would have made it more than half day. I think I underestimated the time. So up to this I will run. See, to run this node you don't have to run all the preceding node. What all you have to do to run a node, right click the button and simply put this execute. It will execute the nodes. automatically. See here, if you get the green, that means the node has worked. This becomes green. If it is an error, this becomes red. And when you move the mouse pointer here, below this you get a rectangle which gives you the error what you have committed. It is very simple to identify the errors. You don't have to go somewhere else and search for this. The moment you make an error, you will not get the green traffic. These are traffic lights. Red, amber. Amber means you are ready to go. Green means yes, go, and then there is no case or something. I mean, if it becomes red, that means some policeman caught you. You be there and then pay the fees or something, then I will convert you to amber, then I will allow you to go like that. These are the traffic light signals. These are the classic things. Even if you take HTO.A, RapidMiner and all, this is standard convention that is used in all these products. These are called the workflow products, not menu based product. Your Excel, Word and all, they are menu based. What happens is every time you go for a menu, click it and then execute. No, that is not this. Workflow is the standard convention that is used, and there is something called bigdata.oi. All of them will follow this convention. Amber, red, green, like that. Red means there is some error message. Amber means it is ready to go. You have set up the setting in the node. Green means the node has been executed and some result has come on the node like that. I will just show you the output of this node.
So sorry to interrupt. Wanted to check when do we have Anupama and Aditya come in?
I will just show another 15 minutes at least. I will just run the workflow. Then what happens is the other two workflow, what is called the dictionary based method and n-gram and 2-gram. I won't be able to show it today because I don't want them to wait all so long. So we will take it at some other time. Then we will repeat the program once more. Then I will skip all these and show that other two which are little bit sophisticated method of text analytics, including what we call the BERT. That stands for bidirectional encoded representation of transformers. What happens is that it is a transfer learning model. Somebody has already learned and put those models. Let us fine tune those models instead of building from the scratch and then rerun the model that is built by TensorFlow. So I will not be able to show them today. I will run the basic model and I will show them this is a very poor model I have built. I will give all the data and then all this to them. Let them try to improve the model. It is a bad model I am building here. This is what happens when we build the model first time. Anybody will not build a model with 85% accuracy first time. It never happens. This is always a learning here. So I will leave at that stage. Let that Capco experts also speak today. Let them also get a chance. Then we will come back at some other point in time. On this I will send it. So what happens is the POS tagger, then I will remove certain tags here. So what I am doing is I am keeping only the adverbs, adjectives I will show you the code for this, what this JJ or this Stanford Classic Dictionary. So JJ is an adjective, NNs are all nouns and RBs are adverbs, the VBs are the verbs. See, your English part of speech, there are 130 part of speech in English. Now we don't need all of them. What has happened is Stanford, they have grouped them into some 38 or 39 part of speech. So when I do the POS tagger, you don't get that original 120 part of speech because they say for text analytics we don't need all these 120. And when somebody writes a text analytics program for Indian languages, this has to be written by them. We don't have this. This is for English. English, Arabic, French, they are the languages which NIME has written these POS taggers. For Orissa, Variya, Bengali, Hindi, Telugu, Tamil, whatever it is, we have to write it. There are 1 or 2 startup companies in Orissa, they are working on this. They are funded, I think by the TI project or something, that a central government project. They are funding, one is done there. IIIT is doing part of it for Telugu and other things. IIT Kanpur is doing for Hindi and other our Indian languages. That's what it is. So this POS tagging is language dependent. So for my country you will have to do this, and my country is more complex because you have the bars over the I think English doesn't have bars, then half matras will be there, then double colons will be there. So writing the POS is not that simple for Indian languages. I think that's why they did not write it. So that's what it is. We create what is called the bag of words. So this bag of words will split the sentence, and for each word it will attach a tag. I will just run this sentence, show it to you how it gives. There is a huge increase in the information. See here how many records you have. You have about 3,366 records. When I break it into words and do the POS tagging and then come here, how much it is? Here. 68,141. See the ratio now. Sir, your original text has only 3,361 reviews. That is what it is. And when I did the text pre-processing, eventually I landed with what? I landed with 68,141. Now assume that somebody gave me that Flipkart or Amazon reviews which has 2 lakh reviews. Now what will happen to this? Where will you bring them up? That is why those type of work has to be done on a cloud, or it has to be done in a big data environment. We cannot do it in this environment. It requires this 32 GB RAM or some damn 128 GB RAM machine. It has to be a server. It becomes very, see here, I have my input records are only your 3,336. That is my input rows. After doing the pre-processing, creating this bag of words, I landed with what? Here, 68,000, roughly 20 times is the growth. Roughly 3,000 into 20 is this. Now, if I have 1 lakh records there, 1 lakh reviews are very common. You go to any e-commerce site, 2 lakh, 3 lakh, 7 lakhs. So 7 lakhs you multiply by roughly 3. So 7 lakhs will become how much? 21 lakhs. Where will you store them? That is the difficulty with text. It looks deceptively simple. When you start analyzing it, now you see the drama now. 1 lakh, 2 lakh reviews are very common. Brand reviews, product reviews at that level if you take, and you take my travel sites like makemytrip.com, travelsite.com, and then other trivago.com. No. 1 lakh is nothing for them. They all talk in terms of 20 lakh reviews, 30 lakh reviews on that thing. And your suspicious transaction records. No, 1 lakh is nothing. Nothing. See the problem here. That is why I was telling it runs on an 8 GB RAM. It is very difficult to run this type of workflows on a 4 GB RAM machine like that. See, this itself became 64,000 and odd here. It is showing. I will just open this and then show it to you. We have attached the part of speech for all. This is what it is. It has broken. NN is noun. VB is verb. This is what it is. I have taken only the noun, and then I think adverbs or something. This is what it is. So if you do not do pre-processing, take all those commas, full stop, etc., colon, you are out. So this 3,000 reviews, if you do not do text processing, any, it may not be Python or it may be whatever it is. If you do not pre-process the text, you will run out of memory. You will not be able to analyze 10,000 records. You are gone. Your 8 GB RAM is out. So please don't do it. That's why we have done all the number filter, stop word filter, then all these filters less than 3 characters, all that I have removed. Now you can assume, if I put all these things, this 66,000 something, whatever I am showing here, it will be multiplied by 4 times. For a small data of 4,000 records, to do the text processing, what happened? It became 2,42,000. And if my reviews are 1 lakh, now you can imagine the volume. It is atrociously tough to analyze text. So if text itself is tough, let us come to images. Now you see the drama. If I store an RGB image, of a camera, CCTV camera for 10 minutes. Now you know what it will analyze. It will run out of memory like anything. Out. You take that CCTV recorder or something which you normally put in your houses to see who is moving, who is coming to your house. Now you can see the volume. Text itself we ran into difficulty now. See the picture. It is taken in 3 spectral bands, R, GB. There is a red channel, there is a green channel, there is a blue channel. 1024 into 1024. That became 1 megabit. 1 megabit is 1 picture. 10,000 pictures. Now where you will go? You are out. Pictures has to be stored in a different way. At some other point in time I will show how to store them, because I was in ISRO. For almost 10 years I served in ISRO. We know what to do these pictures. That's what it is. Then we compute what is called this TF and then IDF. Since I don't have time, I will run the end workflow and then show it to you. There is something called a tag cloud. Just like we put these bar graph, P graphs, line graphs for the numeric data, we cannot put these line graph, P graphs, etc. for a text data. This is what is called a tag cloud. A tag cloud gives the pictorial representation of what are the important words in the text and what are the unimportant type of words. All the important type of words will come to the center and all the unimportant type of words will go to the end. I will just run the tag cloud and then show it to you. This is the tag cloud. All the low, size, fabric, wear, etc., etc. They have all come to the beginning. Now this can be customized. There is a way to customize this one. Somehow I am not getting this proper bar here. All of them are coming here. So it can be customized. So the size of the font gives the importance of the text. They all come in the middle. So here that menu also comes here. What color is assigned to what, like that. Somehow I am not able to remove these borders here. Somehow it has become. So at some other point in time I will show you this one. We can adjust all this. Font can be adjusted, the color can be adjusted. So all that word, adverb and all I can make it to appear in different color. Verb, preposition, adverb, noun, pronoun, all that I can put here in different colors. So this is how we pictorially represent the cloud. Then there is something called TF, IDF. We compute. It is something like that. What is the importance of the word to the document? We compute what is called the TF and IDF. We multiply the TF by IDF. That gives you the importance of the word to the document. See, I am mailing all those materials, that reading material. So you definitely read it. I think somehow I underestimated the time today. We will meet some other time, don't worry. This is only one workflow I am going to show. Next time I will show you how I improve the workflow and increase the classification accuracy from some 60% or 40% to 90. I cannot do it today. I will just run the last workflow and then show it to you. This is what is called a tag cloud. We will put a frequency filter and eliminate some low frequency words so that they do not appear and then create a big storage problem here. Then from that we convert what is called a document vector. So this document vector is a vectorial representation of your text. I will just run it and then show it to you. This is very important. I will just execute the node. All the previous node it automatically executes. You don't have to touch each node and then execute. You click the last node and then ask it to execute. The entire workflow gets executed. That is the beauty of the workflow. We are not going into module, line, editing, nothing here. You see, I think in a joking statement I can tell, if somebody knows how to use a mouse, he will use the product. You don't need Python knowledge, you don't need R knowledge, you don't need Java knowledge, nothing is required. What all that is required is a mouse expertise and some basic reading about these nodes. So if it is that is your expertise, you can build the text analytics model in 24 hours. Even the complex model with all the developer app, YAML app, etc., parameter optimization, everything can be built in 24 hours and put to production. You will not be able to do this with Python. You are out. You are almost out. You will slog for almost 10 days or 15 days to do the work there. And if small thing changes, some library version changes, one day the damn Python will be working, next day it goes off. Again you will go to Conda load, pip load, the whole story starts back. You are back in the same boat. Some version will change and suddenly the damn thing stops working now. Again you have Conda install, Conda uninstall, that whole story will start. When you will show to your manager the output, I can produce the output in 2 hours and then show it to them, which is not possible in Python mode of working. You can never do that. So this document vector I will show you too, that shows how the vectorial representation of the text. This is my document, and then you just see how the vector looks. This is what will go to your wherever that word is appearing in the document, a 1 will be put. Wherever the word is not appearing in the document, a 0 will be put. This is what we call a document vector, and I will use the decision tree for the classification. You remember I showed that decision tree earlier to do that sales forecast or something. Instead of sales forecast, we run a decision tree and then classify which news is positive and which news is negative, like that. This is the internal representation of text because computer cannot directly understand the text, so it can understand only numbers. What all I did was I somehow converted that text using big jugglery into a series of numbers. This is what I did. So the vectorial representation of the text, that is called what we call the word map, whatever, document vector. So from this document vector, the other part is common. The same decision tree I am learning, and I will show you the final thing, the decision tree predictor. I will predict, and finally the scorer node is there. I will run the scorer node because my colleagues are waiting. We don't want to keep them waiting. Some other point in time I will definitely get back to you and then explain this. Somehow I underestimated the time, I think. I could not show that 2 gram, 3 gram. I am going to improve this model and then show you how to improve this, because this gives a very bad accuracy. We know it gives you bad. See the time it takes, decision tree, because there are about 4,300 columns here. The text when I convert, it has become huge number here. That's why 1:10 it becomes in volume, or 1:20. One line will become roughly 20 columns there. So if you have 10,000 line, multiply by 20, that is the number of columns it will take. There are other ways of doing it. We convert to a vector type of representation. I am not able to show it today. Then we will use the Keras and TensorFlow. That BERT modeling is there. That will do it if your data volume is very large. I should have run this earlier, I think. Somewhere I reset these notes. Let us wait for a while. Even this small 3,300 records, you see the time it is taking to build a decision tree. This is a 16 GB RAM machine. What I am using is a 16 GB RAM, some latest processor with all that it comes. So normally a heavy volume of work, we cannot run them on the desktop. It is preferable to run them on a server. It can be hosted on a cloud, or it can be your own server, whatever it is. That's what it is. So the TF-IDF is one method of doing. There is something called TF-IDF, that's called the term frequency, and the other one is called the inverse document frequency. That is something like a digital signature of your text. Let me put it that way, you will all understand. Something like it is some 3,000 line or 4,000 lines, somewhere I am going to record them in a bit vector form. That is what we call the signature of your text. That's what it is. I have somehow converted that to a signature. That is your 1-0 representation what I showed. After removing all the punctuation mark, stop words, words less than 3 characters, all that has been done. If you keep all those things, it will become worse. It will become 18,000 record now, not that 6 lakh something. Now you see how much time it takes to analyze text. It is quite a volume. I have taken only about 4,000 records. That 4,000 records have become columns. It has 7,270 columns. See the volume here. It is 7270. That's why it is taking so much time. There are 603 records. I am building the model. I am validating the model on 651 rows just to see how it classifies like that. What I will do, maybe they can give their presentation. If some small time is left, I will show the output finally. This is taking time.
I think that would be a good idea, sir.
Correct. I will get back to them. For some 10 minutes, I will show the output eventually what happened for this.
Sure. So, is it okay?
Another one or two short questions are there, I will answer so that we don't carry them till the end.
Sir, there are quite a few.
Oh, then we will ask in the end. Correct. Let them present. Present. I don't want to cut their time. That is why.
Sure. So, thank you so much, sir. If you can stop sharing, I'll also begin. And while sir does that, as mentioned earlier, to provide an industry perspective today, we have experts joining in from Capco. Capco, a Wipro company, is a global technology and management consultancy, specializing in driving digital transformation in the financial services industry, and with a growing client portfolio comprising of about 100 global organizations. Capco operates at the intersection of business and technology by combining innovative thinking with unrivaled industry knowledge to deliver end-to-end data-driven solutions and fast-track digital initiatives for banking and payments, capital markets, wealth and asset management, insurance, and the energy sector. So, their approach is tailor-made to fit with each client's problem, with an emphasis on building long-term strategic partnerships that foster, collaboration and trust. So, Capco offers a globally integrated service with offices in leading financial centers in 32 locations across Americas, Europe, and Asia. So my pleasure to introduce you to Anupama Rathore and Aditya Pant. Anupama is a senior consultant at Capco, analytics and data science professional since last 9+ years, and she has experience in designing and delivering impactful AI/ML solutions for banking, retail, and loyalty and edtech sectors. She's an independent data science instructor, MBA, postgrad in data science and business analytics from McCombs School of Business, Austin, Texas, and she is a green lifestyle enthusiast as well. And Aditya Pant is again a senior consultant at Capco with 10+ years of experience as analytics and data science professional across different verticals in insurance and consulting space, delivering key strategic projects. He was selected for the pioneer batch of Young Leader with 12 months of accelerated MDP from NMIMS Mumbai by MD and CEO Edelweiss Tokyo. He is MTech postgrad in data science and engineering from BITS Pilani, and Aditya loves comfort food, so he calls himself as a comfort food enthusiast. All right, so Anupama, over to you. You can start sharing your screen.
Yeah, thank you, Sudeep. Thank you so much for introducing us and in fact inviting Capco. Give me a minute. Let me share my screen. So, is my screen visible?
Yes, it is. Can you go to slideshow mode?
Yeah, I will. Yeah. So, thank you, Sudeep. Thank you, Dr. Chandrasekhar. I think it was a very interesting session. I was there in the session, and I feel that yes, NIME is a very interactive platform, and in fact a very handy platform, especially dealing with a lot of business problems, and especially when we're talking in terms of taking those business problems and taking those machine learning problems to production. So, very informative session, and so today from Capco, I'm here to present a stock market prediction and where we've done sentiment analysis.
Anubhav, before you proceed, though we had planned for a break at 12:50, do you suggest that we take the break at 12:15?
12:15.
I meant 1:15, sorry.
Yeah, we can take the break over there. So basically, are you saying that we take the break first and then go with the session, or
I think we can continue with the session and take the break whenever you let me know.
Sure. Okay. Okay.
Yeah, perfect.
Yeah.
Thank you.
Okay. So we're talking about stock markets. We're talking about stock prices over here, and I think there were a couple of questions also coming in asking about financial predictions and stock market predictions, and so I think it's a very relevant use case that we've done. Emphasizing on the fact that stock prices and stock markets, they are one of the most complex areas and very difficult to predict, and in terms of machine learning, it just doesn't mean that we just put in a model and then we get some output. For the basis that there are numeric factors involved when we're talking about predicting the stock prices, and some of these factors are like your investor sentiments, the firm's performance, economic sentiments, economic factors, social media sentiments, and all these things will definitely influence the stock prices. So when we are talking about modeling them, we are also talking about having a good domain knowledge and a good understanding of the stock prices, the stock markets, and at the same time a good knowledge about the company, the domain that the company is into. And so the aim of this use case that we've done is to investigate the performance of these machine learning models to predict the stock market movements based on two major input sources, or I would say data sources. One is the historical stock prices, and yes, taking in the sentiments that is coming in from the news articles. Over here, we're following a very basic and a very layman principle with the fact that if anyone wants to buy if anyone is doing the trading in stock, the idea is that they will buy at a low price and they will sell at a high price. But then the important question to answer over here is, what is that right time, or what is that right picture when you would want to sell a stock or you want to buy a stock? Talking on that perspective, the business problem that we have worked on is that we would want to predict whether the next day adjusted closed price of a company stock will increase or decrease based on the sentiment analysis from the market news articles. And to do this business problem at this point of time, we have considered a little bit on the global perspective, taking in the global scenario, and that is why we've looked into the UK markets more. And to solve this problem, this has been an approach towards solving the problem. Now, when we're talking about solving this approach, the approach over here, it looks like we'll have an input data, and when we're talking about input data at this point of time, we've analyzed the financial news, news taken in from the online sources. There's still much to do in terms of considering social media blogs, and that talking about the Twitter blogs, or we're talking about the corporate disclosures or information about them. But when we're talking in terms of business perspective, what happens is that all this information is not very readily available. So the financial news that we've considered is the public information that we have, and the historical stock data that we have from these online sources. So these are two main sources that we're considering as our input data. To this input data, we've done a bit of feature engineering, and when I'm talking in terms of feature engineering, we've to work out, we've majorly used the text data, and that is used this text data to generate a sentiment score. And that is something which even sir was talking about. Basis what is the emotion, how the words are actually reflecting in terms of emotions, and then they can come up with some sentiments. And when we're talking about sentiments, it is more about your feelings, how you would consider a particular piece. Is it a positive one? Is it a negative one? And that is something which we've tried to convert in and bring it into a score. Over here we've and I'll be talking in a little further what are those different methodologies that we've used. That was about doing the feature analysis in terms of the text, and at this point of time we've just considered the stock prices as is, the openings, the close, highs, lows, and the adjusted close prices. We do want to include technical indicators, but that is something which we're still in scope, that is still happening in. Now, talking in terms of, after doing this entire feature engineering, we've also done a feature mapping of this, and eventually we've come up with building up a supervised learning model, and to be much more precise, a classification model. Classification model, and then we want to also look into the deep learning side of it. So that is again in future, building up a neural net on this thing, and if they impact the stock predictions. To consider and delve in deeper of this approach, this high level approach, this is what has been our major aspects that we've looked into while solving the business problem. One, talking about data extraction. Now, when we're talking about stock markets or stock prices, it is very important that we have the relevant data sources. And when we're talking about relevant data sources, it is also important that we have the most recent data. Now, giving in the perspective and that the whole world has undergone such a uncertainty, which is COVID, it has changed the entire scenario. Now it makes it more relevant that we get those relevant sources, and sources which are available at a huge amount in terms, and there is no dearth of data in this thing, because when we're talking about machine learning, we need more and more data to it. So what we've done is we've extracted data from the from online sources, and majority at this point of time, building up a use case, we've considered Yahoo Finance and investing.com. The time period that we've taken in is from 2014 to 2021, and that is the calendar year that we're considering. And likewise, we've also taken the daily stock prices for the same company, which is company, and their opens, highs, lows, closes, their adjusted close, and their volume. So what is happening, what we've done is that we've made a merge of the same time period and tried to bring in more of text data for the same dates, so that we don't miss on a lot of rows, or we don't miss on a lot of, we don't have a lot of missing data available. So that was in terms of data extraction. Now, when we were doing data extraction, then it is important that we understand that what the whole stock market or how the company is or the domain is. And as I just mentioned, it is important to get a very detailed understanding of the domain, and that is where we've considered, we did an exploratory data analysis where we not just explored the company's stock whom we wanted to predict it, we also explored the other domains. So for example, we took a company from the finance, from tech, pharma, FMCG, and gained some insights, and did some statistical techniques, so used the statistics like mean, the variance, we understood them, and also considered the technical indicators and understood that how that overall the companies in these different domains bring in the whole picture of stock market predictions. So that was on the exploration side, and basis that, then we identified that the target variable, and after a lot of research and everything, we realized that the target variable that we can take at this point of time is the adjusted close price and not the close price. For this target variable, another target variable is again a label variable where we are setting as 1 and 0. Now how do we set this 1 and 0? What is the definition of this binary variable that we're going to set? So what we've considered is that the difference in the adjusted closed period of the current day versus the adjusted close price of the next day. So if the difference of those adjusted close price, if there was a positive difference or there was a price increase, then that was termed as labeled as 1. Otherwise, if there was a decrease, it was labeled as 0. That's how we set the target variable. After setting in the target variable, now comes in the picture of doing the text mining and generating sentiments out of it. So since we have worked our entire analysis and the coding part, we've done it in Python. So we use these NLP tools in Python. One is the NLTK's Vadder module, which generates the sentiment scores in terms of positive, negative, and neutral scores. And we also used TextBlock to generate the subjectivity and polarity scores. What they are, we'll be talking in a while. Once this text mining has been done and we've generated scores for these sentiments for the different pieces of news articles that we have, mapped to that particular published date, we build classification models. And the candidate models that we've really worked at this point of time is Random Forest, KNN, and LDAs. We still want to work on other models, but these are the three main models that we have come up with. Precision is something which we've considered as the model performance metric for the sole reason that it considers into exactness. Now, there is one very important aspect when we are solving this problem, and that is the interpretation part of it. We can do a lot of other things, but at the same time is that we have to make it very interpretable to business. If certain things are not interpretable to business, even if it is a very good model, it might not be expected. And when I'm talking in terms of interpretation, it has to be explained in a layman term that even a non-technical or a person non coming in from the machine learning or the data science or the analytics background can actually understand. So that is the reason why we've kept precision as a model performance metric. Talking a little bit about what we did in terms of data pre-processing. So we've got the company's data, the company's historical stock prices from 2014 to 2021, and at the same time we also took in either the company or the domain in which the company is, that company's news articles related to it. What we had, and this is something which took in the maximum time in terms of scraping the data and seeing that the data, that the text data is relevant data. So in Python, what we've used is we've used Selenium and the beautiful soup packages majorly to extract the text from these HTML sources. There are definitely other ways, but yes, this definitely takes a lot of time in terms of getting the right amount of text data. Getting the right amount of text data and then doing a lot of text cleaning to it, removing these unwanted spaces, breaks, unwanted trailing characters, then at the end it makes sense. And as sir also mentioned over here, setting in terms of those filters, because it's only those words or it is only those sentences that are more meaningful, and that is through which we eventually come up with a score. Now, for demo purposes and to get a clean output of it, we've dropped all those rows which did not have any published dates or duplicates or duplicate dates. And also, if like for example, if you go onto investing.com, from there you will what they do is multiple sources of information or news comes on that same website. So what we've done is we've combined those multiple or similar kind of news on that particular same date, just to avoid duplicacy, and it takes like an extra toll on the whole processing and the tool. In terms of feature engineering, which I've already mentioned a while ago, we took, yes, adjusted close price as the target variable, and then we created an indicator variable, which was our label. And below here is a demo that we've, a small snippet which I've shared. If you see over here on, say, 2nd of May, the adjusted close price of this company was 3,750, whereas the next day's close price was 3,648. So the difference over here is definitely negative, and then the label has been tagged as 0. Likewise, if you see on 7th of May, the adjusted close price was 3,612, whereas the next day's price was an increase, and we've termed that label as 1. So that is how we've created the target variable, and this is the kind of feature engineering where we've done over here. Now, here we're talking in terms of the sentiment analysis and the techniques that we used. So, spending some time on this slide, when we're talking about doing the whole sentiment analysis, the aim is to actually get what is the emotion or what is the attitude of the speaker, the writer, and what is the overall context, whether it is sounding positive or negative. And basis that we would want to bring in that sentiment, and basis that we want to predict that yes, the next day will it help in increasing the stock price, or will the stock price decrease. So two major tools that we used, and one is natural language Hash Toolkit, NLTK. So it is a kind of a tokenization method. In simple words, if I'm just talking to tokenize, doing the tokenization method is like I'm creating a list of words from the different strings, and setting those words in different lists or in different tables. One can be a positive table and one could be a table for negative words, and as many of those positive words are being included in that piece or in that document, we are increasing in the count. So the difference turns out is coming in from the counts of positive words versus negative words. In NLTK, so there is an inbuilt module which is Badder, and I've also shared the GitHub link of the developer CJ Hudo. He's the one they have developed this module. In this module is like an easier version of not creating like our own lexicon, but an inbuilt lexicon is been there in this module. And how this module works is that so some examples like if your document or if the piece has words like completely, so that is going to boost a score and it is going to be more towards the positive than words like slightly. It will reduce it. On the other hand, it also considers capitalization and punctuations. So if you've written great with an example over here, great with exclamation marks will give a stronger effect than just great. Negations, isn't, doesn't, they will actually affect the outcome and they will give you a higher on the negative score. So using this module, below is a snippet that I've shared of how it has worked and how we can interpret this. So in this table below out here, if you see on the first row, the title over here, it says that UK shares lower at a close trade, something about investing.com. It is coming in, and it is pretty jumbled. So just to explain, I've kept it here, emphasizing on the first sentence that it is lower at close of the trade. And there you see, if you look at the negative score over here, the negative score is comparatively higher than the positive score. And then there is a compound score also. Now what is a compound score? A compound score is nothing but it sums of all the words in the lexicon and it has been normalized between -1 to 1. So over here it is giving a negative effect to it. Likewise, the second row has a positive impact, that the shares have a higher at the close of trade. And so if you see over here, it is slightly positive over here. Since over here, definitely this is not there because I've just put into 2 decimal points. But the compound effect, if you see, so it is turning out to be positive. So this is an inbuilt model, inbuilt module in Python which we've used. And there's a list of words and things inside Badder. Depending on the problem statement, depending on what domain you want, we can consider the different lists and the different lexicons that have been created. That is one approach which we included to convert the text into sentiments. And the other approach that we did was using the text block, basically bringing in the polarity and subjectivity to the statements and the sentences. The difference over here and I just missed it. So NLTK will be majorly used. It is a module to use. It looks into words and emojis. Whereas text block will majorly look into formal languages, statements, and sentences like that. So it throws out 2 major output, and that is the polarity and the subjectivity scores. What is polarity? Polarity is, it will give a score which ranges from -1 to 1, where 1, if the score is closer to 1, then it means that the entire statement looks positive. And subjectivity, on the other hand, it is generally it is referring to the opinion, the notion that has been coming out, and it will give a score again in the range of 0 to 1, where 0 is saying that the statement that is been given, it is a very objective statement, but if it is closer to 1, it will say that it has a subjectivity into it, or it has a perspective to it. So these are the 2 main text mining techniques that we've used to generate sentiment scores. And finally, the table, this is how our final table looks in when we are wanting to build up a classification model. So at one hand, we have the historic share prices, that is all the, and this is basically on a date level, more like a time series data. And on the other hand, we've just generated the scores, and we've just used the scores, that is in terms of subjectivity, polarity, compound, negative, neutral, and positive, to analyze the text data. And the label is the Y variable that we've considered. This is the adjusted closed price. Now, looking in terms of the classification models, there are different models that we can build, but being the candidate models, these are the three models that we've worked on: linear discriminant analysis, k-nearest neighbors, and random forest. And for these models, how we've done the train and test is that being into time series data, we've done a 80-20 splitter in the train and test. The data is of course not split randomly, just to avoid the occurrence of overfitting issue or a look ahead bias. And also we've tried to maintain a balanced class. So when I'm talking about being a balanced class, there is equal number of positives and a good number of positives as well as negatives in the entire data set. We've also scaled the data set because just that we don't want to, especially like a model like KNN it is definitely impacted by the magnitude of numbers. So to look across all these models on the same scale, so we scaled the data. And again, when we want to bring in an explanation to why the model has been done to business or explaining it to a client perspective, we've considered precision, just saying that yes, and it is easy and pretty much interpretable. Looking at the results of these models, so now in the stock price prediction, both the aspects are important for us. It is not just that I'm looking at only the increase, or it is not just that I'm looking at only the decrease direction. So a one-fit model will not really work, and that is the reason why we figured out that a random forest classifier is a better model in terms of precision when it is predicting the increase in the stock prices, because it is giving a 63% precision. Whereas a KNN model or a k-nearest neighbor model is a good model if we have to predict the decrease in the price of that particular time. A linear discriminant model, we did it because it is a model which gives a good separability in the classes, but eventually looks like the model did not throw out a good precision values. So we considered KNN and random forest. Now we would want to further build on neural nets, and we would want to also further build on stochastic gradient descent models, and look into it, that how it is working overall, and how it is helping and improving in the model. And so here is the last part over here is that this is what we are further looking in. Definitely, if you look at the metrics, and we look at the model performance, 63% or 79% in this model, we've achieved it, but that is quite a small data set that we're talking about. And again, when we're talking in terms of stock markets, the biggest challenge is scraping the data. So as more and more data is coming in, we have to create more and more lexicons to it, defined, cleared lexicons towards that particular domain. So basis that, the future scope that we want to build on is generating more and more additional sources of news from different sites, or if we get the corporate information, because that is the more relevant information. That will definitely help us to build a better model. One is that we have to look into. Another is, at this point of time, we just explored the NLTK and the WADR modules. another approach could be creating our own corpus, creating our own lexicon about it, and that will definitely require more of domain expertise coming in, and then trying in these the classification models to it. One very important thing that needs to be explored is the technical indicators. So basically, the moving averages, the relative strength. Bringing in those things in the instead of just taking in the historical stock prices as is, and then running in these same models and seeing how this impact is. And at the same time, as sir mentioned, BERT is something which is what we would want to work, and we are working on, because we believe that yes, the stock prices, BERT is a model where stock prices, the prediction, it will really improve, and it will be interpretable at the same time to the business. So yeah, that's what we've been doing from the entire use case side. Any questions? So
I see there are few, Anupama. I'm going bottoms up. So there is a question from Rishi who's asking how were other factors affecting stock market on day-to-day basis controlled or used in the model building?
what can we mention what exactly factors that is he? So basically, Rishi, at this point of time, other factors, if you're talking about technical factors and indicators, no, we've not considered at this point of time. So our emphasis was majorly to look into sentiments only, and sentiments coming in only from one source, and that is the news sources.
So Rishi is mentioning it's the movement of currency.
Yes, so we have not considered that yet, Rishi. That is something, and that's what I mentioned. That is something which has to come in the model. This is a very base model, Rishi.
Yes.
A lot of other things can be done to this, but as in one, and that is exactly where even sir explained that to get into the details and to get into those advanced versions, the most important thing is that the basic version has to be correct enough and interpretable enough that we then move to the advanced versions. Because for anything that we do, we have to explain the why behind it to business.
Just to add, hi Aditya here, Rishi. Sometimes lot of these information, if there is a very high fluctuation, they get reported on news. So by that way, this gets implemented or this gets incorporated in the model. So if there is a very small fluctuation or movement of currency, it may not affect that much to the stock price, but something which like if there's a movement of 5 rupees in the dollar price in the from 75 to 80, if there is a big jump, usually such things get reported, and in that way this gets this will get affect this will, we are able to track the overall sentiment on the price.
Yeah. Next question. I hope that answers Rishi's question.
Yeah, Aditya has already answered few of the questions which were there.
Okay.
And this is good for now. What we can do is hand it over to Professor Chandrasekhar, so that sir, how do you want to do it? It's already 1:17.
No, another 5 minutes only I will take and I will close it. Just that output I will show it to them, that's all.
Sure. There are few questions I think you can.
Sure. Output has come, so I will just show it and then tell them how your further models can improve that output. I just showed them the base model, that is the decision tree.
Sure.
So we will see what addition thing can be done. There are 2 more models here. What I will do is the data.
Sorry to interrupt. I wanted to also have Sumit come in for 2 minutes. I hope
yes.
that is fine.
Sure.
Perfect. Let me. So, ladies and gentlemen, please welcome Sumit Pai. He leads the data and analytics capability in Capco India and manages DNA portfolio for Capco's largest banking client. Has over 2 decades of experience in banking and insurance industry across US, Europe, and APAC, and brings extensive experience in data and analytics space. And he's he's working with us, collaborating with us, that is NASSCOM, to contribute back to the industry in various initiatives. Sumit, over to you.
Thank you very much, Sudeep. Good afternoon, everyone. Great to be part of this excellent session. A lot of insights. Special thanks to Professor for giving us great insight. I feel very excited to listen to Professor, and I always feel that there's a lot for us to learn from him. So thank you very much, Professor. Great listening to you again. And on behalf of Capco, I definitely would like to thank NASSCOM and Sudeep, especially for providing us a platform to give back to the industry. That's what we look forward to. We would like to continue to do so. So looking forward to many more sessions, and support from both of you is really appreciated for this session. Thank you very much, and have a wonderful day.
Thank you so much, Sumit. All right, Professor Chandrasekhar, over to you. We can.
Screen they are able to see, no?
Yes, sir.
This last output I will show. This scorer. Very bad thing. What has happened? Out of the training set, positivity is all right. This negative part you just see. What has happened? 116 negative news has been classified as positive, and then 27 only has become negative. So this is a very poor accuracy. I don't think anybody accepts almost this much mistake any classifier will do. So that is the summary of this. So there are 2 more workflows I am sharing here. There is something called Ngram. Instead of taking 1 word at a time, we take combination of 2 words and 3 words, convert that to a document vector, and then run the classification again. This will definitely improve the classification. And there is one unsupervised classification where we simply count what she mentioned, that positive words, negative words, and try to label it. These are the 3. So that's what I will just send them to you, and then they can play around. 9 is completely free, you can download. Then at the same time, this is what I am telling. This positive news to negative news ratio is very poor here. 809 to 2557. This is very poor. So what you do, take only 50% of this, rerun this workflow again. You don't need any programming language here. Simply run the workflow. To run the last workflow, what all you have to do is take this last item, just see here how to rerun. I will just reset the node. All these nodes have become reset. So this has become amber. Amber means it is ready to go. So what all you have to do is you click this right button and then execute. That's all it runs. So I have not made any changes here. And if you have some other review, I will send another review set for that mobile MI phones or something. You simply change this Excel reader and execute the workflow. We are not touching the workflow at all. That is the beauty of this. No editing, no code editing, no changing the file or something doing. So simply change the input file here. Then what all you have to do is you come to this last. Let me reset the workflow here. It has become amber here. That means it is ready to run. What all you have to do is come to last. Click this right button, simply do the execute. That's all it runs. I am not touching anything. Simply you see here queued. That means this queue will stop, and then automatically you will get the result. Then BERT I could not cover this time. What she also mentioned, which stands for bidirectional encoded representation of transformers. Maybe the session was very interactive. I am sure we will hold one more session where this basic I will not cover. I will cover the other 2. There is a dictionary lookup here it does the classification. And there is one more card, n-gram and 2 grams. Instead of taking one word at a time, we take the combination. The limitation of n-gram is it takes only the previous word, it does not take the following word. BERT takes both. We move backwards as well as forwards. That is the benefit of BERT. That we will cover some other time. And what else? Here I will show them something here. It's open. The entire thing I will mail it to you. These whole things are there. Workflows are here. There is a hotel booking site also. This is a real life data only. You can play around with that. What people are speaking. Particularly, I think this was taken from Make My Trip, who have written badly about the hotel. I think OYO also, which are the dangerous ratings. Somewhere they will say mosquitoes were there, bed bugs were there, all those type of negative reviews you find here. This is one of the questions they raised earlier. If negative reviews are there, what do we do? Here this data set contains more negative reviews. So what you do, downsample the negative reviews now. Let the positive come on the top, and there is something called a topic modeling I could not cover today, so we will cover some other time. Then we have the chi-square keyword extractor and the network keyword extractor. So what normally we have to do is take both the three algorithms, take the common keywords which all of them are finding, convert that word to vector, then do the classification. We have used only the simple decision tree, and next time we will use the Keras and TensorFlow and then see whether deep learning works better for them. I have given some, all these I will mail it to you. Whatever I am showing here, this 9 basic, quick start, text processing, POS tagging, and there is IDF computation which gives you the importance of the work to a document. I have written a small Excel program here. I have taken 3 sentences and then show you how the IDF is computed, which NIME automatically did it. There are 1 or 2 books here. There are 2 PDF books here. One is by Charu Agarwal, who is from that IBM Watson Research Center, again happens to be my IIT Kanpur person only. He did lot of contribution for that Watson. He wrote that text analytics part of Watson. There is another text mining book which is used to teach the course. So both of them I have put here. Along with the workflows, with the data I will mail it to you. Please download NIME from that site. Add the text analytics extension, because when you load NIME it doesn't come, only the basic module comes. Go to this install extensions, that's all, it is very simple. Click this file, go to this install extensions, all of them will come, only tick them, they will come. And if some of
കണ്ടെടുക്കണം ചെയ്യണേ
and even the determinants of the bid ask price also it has been used, which is used in that algorithmic trading.
Okay. Sir, in fact, this was a request from Venkat saying that, can you show a sample of audio voice pronunciation sample? I think we can do that next time.
Yes, I will show you, I will send a workflow which takes that audio voice and then do the text analytics like that.
Sure. And Mahesh was asking, where can we find the steps that make up for this, the workflow which you were showing? Where can you find the steps?
No, I am sending that manual, the quick NIME, the text analytics using NIME.
Okay.
I will send it to them so that it is here. NIME text processing introduction, this is here. This covers that.
Got that.
To start off with that, one more is also there here. I think 2 I will send it to them.
Sure.
Text analytics with n-gram is here, HTML file. Then if they go to Naim site, put any keyword, it extracts all the blogs, it extracts all the FAQs, all that will come there.
Okay. Another question from Venkat. Is it possible to differentiate the context emotions based on, say, UK slang used versus US slang used, especially in the emotion, if the emotion is an angry situation?
This will identify the keywords. That has to, there is something called a dictionary lookup in Naim. I did not show that. What has to be done? You have one dictionary there. That dictionary contains those slang words. Now there is another dictionary which does not contain, that has to go there, then other process flow remains the same. There is a mechanism to do that. In Naim, it is available. That's called the dictionary lookup node. It has about 90 or 120 nodes for text analytics. You know what all I showed is only 10% of the nodes today. It is there. It is there. There is a dictionary lookup. He will give that slang word, and in the text or something that slang word may not be there. So we will tag that with the part of speech. Then other processing will continue.
Sure. And there are a few more questions, and my colleague is pinging me for the feedback form. If you allow me 30 seconds, I'll just
sure.
Link here so that everybody can share their feedback about this session. So everyone, I'm sharing the feedback link on the chat. If you can quickly fill that up, that would be great. And so coming back to the question from Ravi, he's saying, while converting text to document, can you use a model which can mark the positive sentence or the negative sentences?
So positive negative can be done only with a dictionary lookup.
Okay.
So that does, it parts only the part of speech like noun, verb, adverb. Then there is a tag filter. If you filter the verbs and then adverb, that is where the action is.
Sure.
That I could not show today. I think this will become a one-day session. They are very enthusiastic, this crowd. So probably at some other point in time, I think this 4 hours looks to me insufficient now.
But having said that, for the audience, there is a follow-up session coming up next week, that is on 27th. That would be on demand forecast.
Yes. All are welcome to attend.
Absolutely, and I'll send the invites to everybody. Question from Mr. Ramdas, who's asking, can we use Naim pipeline in deployment for production?
It is available. He is right.
Okay.
It can be deployed.
A question from Satish, can this tool be used for transformation or process improvements?
It is there something related to quality, is it?
Well, Satish, if you can, ask a question.
Expand that a little, that will be beneficial.
Yeah, I'll just ask Satish to probably, rephrase his question if possible. And Ravi is asking, is Naim have a non-GUI mode?
General license, is it?
No, GUI.
Oh, graphical.
Yeah.
User interface, I think there was something called a developer version which allows them to, I think that part I have not explored.
Got it.
Because I just use this and then my problem is to teach to the students. If I take that Python code and add to them, what they will do? They will just leave my class. We will keep them in the I cannot, that workflow what I showed today, if I convert to a Python code, I will end up with 500 or 400 lines of code. Then what do we do? And most of them will ask me, sir, we are not coders here. What do we do with this? You please tell. What shall I do on the ground after all these outputs?
Sure. And this is the last question from Rishi. How do you do data scrapping, and does this software allow to do this?
There is a web scraper here. HTML web, it can read HTML document. There is a web scraping tool also, I think there are another 1 or 2 web scraping tools. They can use it and then bring that HTML or whatever format into Naim, use the Tika parser and then continue. If they are not comfortable with this, there are web scrapers available. They can download it, and then what happens, there is a HTML reader here. So using that 9 workflow can continue.
Sure, sure. Well, with that, sir, no more questions. Thank you so much. And, I'm feeling good that we have been able to answer all the questions which came in. My special thanks to Anupama, Aditya, Sumit, and you. For making this session happen. I'm looking forward to collaborate more. Professor Chandrasekhar is always very dear to me, so I'll get more of his time. Sumit, Anupama, Aditya, looking forward to collaborate more. And for the audience, thank you so much for patiently waiting, asking your questions.
Yeah, you are highly interactive. So very good.
Yes, absolutely.
A very good
Absolutely.
session, not one way. Generated. As teachers, we have to do some transfer learning. That is what it is.
Absolutely.
And in fact, when I went to US, I still remember that the teacher spoke 10 minutes and he asked 10 questions. None of us asked. He walked out of the classroom. He said nothing. You are simply keeping quiet. This is not convert to next class. You come and whenever I stop, I will ask you 10 questions. If you do not ask, I said the class is over. I am leaving. You read the rest. I will stop now. I will start next chapter. I think here we are taught how to answer. US education teaches how to question.
Right.
This is the basic philosophy difference between the two countries.
And
Because I happen to study in both the countries.
we are getting some great feedback also from the attendees, saying, Rishi is saying very insightful session, Arijit is saying, very informative, and thanks to you, Professor. So we look forward to having you all back on 27th.
Yes.
And as I had mentioned earlier, please, fill up the, survey form to get your feedback so that we can make these sessions more interactive and, valuable for you. And I'll be sharing the recording as well as the information.
All this course material also I will send it to you. You can combine with the Capco material also, and once for all you can send those files.
Absolutely. I'll probably upload it in a shared folder and share it with them.
Okay.
All right. Thank you so much.
Thank you all.
everybody.
Thank you all for patience hearing.
Thank you so much.
Good luck.
Thank you, Dr. Chandrasekhar. It was wonderful interacting with you, and it was wonderful seeing this, being in this session. Very, very informative.
Thank you all.
All right.
Thank you.
Thanks, everyone.
Thank you, sir.
Thank you.
Recording